Hello, hello. Good morning. Ciao. You will learn much more than ciao in a week. So let's open the fourth winter school from Ediss. So welcome all of you. So thanks for coming to L'Aquila, to Italy. I'll show you later the program, and we will also introduce the staff members, because we know that maybe you don't know all of us, okay? But let's start now with an introduction about our department by my colleague Vittorio Cortellessa, which is the Vice Director of the Department of Information Engineering, Computer Science and Mathematics. Okay, thank you.
So welcome from my side as well. Actually, I'm forced to be here in an institutional role, but I'm happier to be professor in computer science, and also I contribute to the program. Ciao Kartik, how are you? I will give just a short introduction of our institution. You probably already know something. We are an institution which is made of 7 departments and 3 Center of Excellence. The departments, they are shared in engineering discipline, civil and industrial, medical discipline, like applied clinical science and clinical medicine. And then there is this department. Our department is a mix of mathematics, computer science, and computer engineering. Actually, there are not many departments like this one in general in Italy, because we had this reform many years ago to make department larger, and I think we were lucky enough in our university to be not fighting too much each other, and we could make this department, which is joining these expertises in mathematics, computer science, computer engineering. We have control theory professors and other things, and I think it's an added value. Also, I want to outline that as witnesses here today, our department is the department that more contributes to the international programs in our university. And personally, I think I teach this course, software quality engineering, in the first year of our degree, and also someone has attended. And this year I had 35 students and 16 nationalities in my class. And I think this is a very important value, because beyond the notions and experience at university, I think these are the most valuable things that you can learn. You know, making a project with the 2 person that comes from other places in the world is something that will make people growing much better than other ones. And yes, we have three center of excellence. Some of them are more consolidated. The one on the meteorology, telesensing and environment, and model prediction of severe events, CTEMS. Another one on embedded systems, which is DUCE. And the most recent one is XEmerge, which is this center of excellence on autonomous vehicles, which is something that is very, let's say, studied all around the world. Yeah, this is our department. Our department is basically made of 3 different areas in terms of research: computer science, as I told, computer science, computer engineering, and mathematics. Also in terms of, let's say, educational program. Numbers, we are 39 full professors, 42 associate, and 44 researchers. The other value in this department is also the fact that we participated to international call for projects, for research projects, by joining our expertises. This is not happening at the level that I hope. So I think we can exploit more our synergies because of different, background and different expertises. And still, I think the collaboration is not as much as I think we could have. But we will work on this. Yeah, computer science area, of course, it's more or less, let's say, half of effort in professors is in mathematics, and then quarter and quarter in computer science, computer engineering. We are 8 full professors, 12 associate, 11 researchers, and PhD students and other ones. And yeah, not bad. Our educational offer, of course, as a bachelor, a master of 1 year in mobile and web technologies, and master degree in computer science that you know very well, with the different, let's say, curricula. And then we have a PhD in ICT. Also, this PhD is a particular one because it combines, you know, expertise in computer science and computer engineering, including telecommunication engineering, control engineering, and these things. I've been coordinator of PhD programming for 7 years, up to 1 year ago, and it's very interesting. Even there are different interests and different disciplines, and they could be exploited better than this, but at the same time there are PhD students in different, let's say, domains, and this is very fruitful for the growing of young people, in my opinion. Yeah, curricula in our master degree, of course, Henry is, let's say, the artifacts and the owner of all of this. I mean, most of them, especially for international curricula, which are the, let's say, the source of many of our students. So it's this is due definitely to the Henry's effort since many years. We have two standard curricula, which is advanced software engineering and ICONDA on artificial intelligence, complex network and data analytics. Then we have applied data science, which has been an effort in the last few years. It was born 4 or 5 years ago, I think, applied data science. The idea is very, is very valuable, but it's difficult to realize, to implement, because it's a master degree where in the first year, people with bachelor in different disciplines, from economics to medicine to computer science, they can enter and have a common year on data science. And then the second year they are specialized in one specific domain. So actually the expertises are so different in the first year that this is a great challenge. We took 4 or 5 years ago, and it's still going ahead. So it's interesting. Research areas. We are quite active in research, software engineering, model-driven engineering, artificial intelligence, data science, algorithms, theoretical computer science, and operational research. Quite different, and the level of research is quite good. And this is an important aspect, because next slide is probably the most important one of my presentation. You are young, and I think in academic environment, it's very, very important that the quality of research is high in a certain academic environment, because without a decent level of research, wherever you study, the quality of education and the quality of teaching cannot be so high. Of course, university is not school, no? And if people teaching you, they are not active in research, they cannot teach you very well. Yeah, foundations, there are some foundations, but then there are other topics, they change every time. Now it's artificial intelligence, data science. I entered programs in computer science in my bachelor in 1985. There were still some dinosaurs out there. Yeah, it was 1985. And I've seen so many topics changing in computer science along the years that is very, very important, you know, to acquire foundations, but to be exposed in environments where people, they do good research, because this is the soul of an academic, of a good academic environment. That's why I drawn this tree. The tree is producing in one of the leaf a fruit, which is the program you are involved with, which is Ediss, with many interesting courses: software architecture, model-driven, architecting intelligent systems, autonomous systems, and other very cool topics today. But the roots of these three, they found on foundation, on good research in several domains. This is very important. Otherwise, you cannot provide the good and nice, you know, programs without these roots. So that's very important, and remember, when you are exposed to academic environment, to check and to see if there is good research there, because this is very important, okay? And nothing else. I have just 2 pictures now to show, because you are young students, and I think it's very important to make an accent on people, because beyond any topics and beyond any progress of research and educational programs, there are people. And I want to show you two pictures of two persons. One is this one. All of you, you know DeepSeek and what happened a few weeks ago, no? This event, I think, is very important. And I think it's a light that outlines some aspects. A few weeks ago, this event of DeepSeek, you know, demonstrating that they could update the LLM with 5 million instead of $110 million, made NVIDIA losing in New York affair 17%. It's a light. And why it's a light? Because those people, they didn't use any GPU, any new GPU, any new technology, anything. Yes, they used probably public data from other ones, fine, they were there, they used it, who knows? And they used the new ways to train, you know, and to feed this system. New ways. So meaning that they've used mostly everything that is from here to here, and nothing else. Right? And something else probably, but not more. So this means that the education and the way you grow your own knowledge could still be stronger than New York, you know, affair system, you know. And that's something that I think is a very nice aspect. So then there will be other demonstration in the next few weeks that this is not so strong as it has appeared, but I think it was something that was outlining one aspect, which is if your creativity and your fantasy and your basic knowledge, they will be the most important value you will bring with you, okay? And not only technology. Technology disappears, languages disappears, everything disappears and changes. And in order to be, now the term that resilient, no? In order to be resilient to changes, you need to acquire foundation and good knowledge that you will bring with you for the life. That's the most important. That's one. The second one is this person here. This is a professor, he's called Steve Koonin. Steve Koonin is a professor at the New York University. He was here 5 years ago, he was visiting l'Aquila, and he has created at the NYU, he has created the Center for Urban Science and Progress. This is a research center. They provide some educational program on smart cities technologies, okay? And he has started a program before with the mayor of New York City for collecting metadata, for collecting data about the New York citizen. Like, for example, the runs of taxi drivers. I mean, the length and the time. The time in buildings, the light were going on and off, you know. 40 types of metadata, okay? And then they try to offer new services by joining this information, new services to the population of the city of New York. And the nice aspect was that he was going around the world in Europe because he told, I know that the data that we collected is of value and we can create services. But I'm recruiting young people, you know, millennials, the ones that were born in the 2000, because I think they have creativity and fantasy enough to create original services instead of us. So your own creativity is very important to elaborate those data. So computer science is not just about data and code, it's also about using creativity for improving the world and making machine doing boring things that we do instead of employing humans. And that's all. Enjoy your time in l'Aquila and enjoy your time in general.
Thank you very much, Vittorio. So Sebastian, do we want to, I'll show the program, so to give a little bit of some more information. So let's first load the program and then we invite the staff to come. Maybe we do in parallel, he's still sleeping.
We start with the photo. Okay, so you will spend your week with with us, and I think you all know Henry. Yes, you all know me definitely. Yes. Then you say your name and.
Oh, okay. Hey, hi all. Very good morning. My name is Karthik Vaidyanathan. I'm an assistant professor at the Software Engineering Research Center from IIT Hyderabad, India. So L'Aquila is my like my second home. I did pretty much of my master's, PhD, postdoc here. So great to be back. And of course, I'll be interacting with you maybe throughout the week. Thanks.
Hello, good morning. My name is Grace Lewis. I am a principal researcher at the Carnegie Mellon Software Engineering Institute in Pittsburgh, PA, in the United States. And I'm very happy to be here. I'm going to be talking to you tomorrow.
Hello, my name is Marta. I'm from the UIB, and I'm the administrative side of the UIB team. I'm the only one here this year, but you will be meeting the professors on Thursday by conference.
Hello everyone, I'm Letizia Giorgetta. I'm from here, from the University of L'Aquila. I'm so glad that you are all here. Thank you so much for coming. I also work in the administrative part, so to say, your organization, logistics, and your personal assistance, let's say that. So you are very welcome here.
Hi everybody, my name is Sinisha, working as a coordinator at Mälardalen University in Sweden. It's a pleasure to be here. I would first like to welcome you all here, and special thanks to Henry and Letizia for organizing this great event. I hope you're going to be enjoying yourself, and see you.
Hello, my name is Mikaela Strömbori. I'm from Åbo Academy University, where I work as the administrative coordinator of the Ediss program.
Yeah. Hi, I'm Bogdan Iancu. I'm a university lecturer in computer science and engineering at Åbo Academy. I'm very glad to be here, and I'm looking forward to a great week. And thank you everyone from L'Aquila for everything.
Hello, I'm Hergus Regia. I'm a postdoc researcher at Åbo Academy, as probably you know from Ediss' last intake and this intake. I've been doing some courses related to machine learning. And I'm also happy to be here in L'Aquila, and thanks also for organizing this event.
And I'm Maxi Penta, professor of software engineering at the University of Sanya, and we are going to have some fun together in 10 minutes or so.
Okay, just some logistic for today, just to let you know. So in a few minutes, we'll start with the presentation from Max. Then, as you can see, we have coffee break from 11 to 11:30. So coffee break will be downstairs, okay? We have 30 minutes, so it's not too much, but on the other side, you know, it's a limited time. So be sure that when we go, we start with care, because you see that the stairs are a little bit, you know, slippery. Then we will have at 11:30 another talk from a company which is coming that is close to this, is in this region close to L'Aquila. We have lunch, again, is downstairs. I'll show you later, you know, the area. Then we have Kartik Vaidyanathan, which is presenting in the afternoon. We have some companies with show presentation from 3:30 to 4:30. And then we go to the Maxi Museum by walk. It's about 10 minutes from here. It's a modern art museum. We will have a guide, and they will explain a little bit of this modern museum. And then you're free. So you can organize for your own dinner. I think that you already know that we need to make a reservation later on for the dinner, but we will give you a little bit more information. You have a 20 euros coupon, each of you, that you can spend in one of the restaurants that we have an agreement, and we will tell you a little bit more later how to get organized to go to those restaurants. But now let's start with the scientific program. Let me invite Max Di Penta to come. I'm very pleased to have Max over here. You know, he's a frequent, let's say, participant and coming here in L'Aquila quite frequently. He's from University of Sannio, and I can tell you, he's one of the most known Italian researchers worldwide in software engineering related topic. I think that I'm not saying anything wrong if I, you know, recognize Max as one of the most known researchers from Italy all over the world. Okay. So Max works in topics, many topics related to software engineering, including mining software repositories and verification. And in the last few years, he has been working a lot in the integration of you know, machine learning and LLMs into software engineering. As you know, in L'Aquila, our program builds on top of software engineering. So let's say that we are the, in a sense, the software engineering side of Ediss, where we integrate in software engineering traditional processes with this machine learning, and more recently LLM, and whatever is related to how to engineer a software that has some intelligence, that has some ML and AI components, okay? So then we try to have a program that reflects a little bit on this you know, dual role of software engineering on one side and machine learning, LLM, AI on the other side, okay? So again, I'm very happy to have you here, Max.
Thank you.
And I know that we will appreciate a lot the talks. After the talk, you know, we have like 90 minutes. This means that part of it will be left for questions, okay? So I don't know if you prefer a question during the talk or after. Anyway, we have some mobile microphone over here, so I'll take one of those. If any of you has questions, please feel free even during the talk. Max, I'll leave it to you.
Thank you, Henry. So, as Henry was saying, I'm coming here to L'Aquila quite often, and I will explain where I'm coming from. This is actually the third time in 12 months. And although last time I was in this building was 17 years ago for one of the most important conferences in our field, which is the International Conference on Automated Software Engineering, which happened actually in this building in 2008. So, what will be the topic of my talk today? I will give you some technical detail about using LLM for software development, but not so technical because, as I will explain, from a software engineering perspective, the way we can make the adoption of this new AI technology in software development does not really concern a lot the specific technology, but more the way it is integrated in the process with the people, with the regulations, and so on. So, yes, okay, sorry. Okay, can you hear me from the back? Yes, I guess so. And yeah, another thing, oh, this is interesting. Okay, this is what I call interaction. So, if it is possible, feel free to interrupt me during the talk because you will get better context for your questions. So, first of all, where I'm coming from. So, the place where I work is actually here, Benevento, which is 1 hour north than Naples. And the university is called the University of Sannio. Sannio is actually this geographical region, but I don't live here. I actually live a little bit northern, which is here in Molise, Campobasso, and so I just drove for 3 hours to come here. As Henry said, I have several research interests within software engineering, especially recommender system for software developers, software evolution, which is my long-time research topic, but also legal aspects in software development. Today we are going to talk a little bit about this aspect, which is very important with LLM, in my opinion, and software analytics in general. I also want to tell you about my teaching because what I'm going to explain in terms of research also interacts with my teaching. I teach natural language processing to bachelor students. I teach advanced software engineering to master students, and I also teach part of a video game development course to master students. I'm really into video game, and developing video game is challenging, as I will explain in a while. Outline of my talk. First of all, I will summarize what happened in the last few years in terms of the rise of generative AI and what are the promises and challenges in adopting it for software development on the one hand. On the other hand, I will briefly touch what happens when we develop AI-intensive systems, so when we integrate those LLM in our own system, what are some challenges and risks. So let's start from what were the usual development tools once upon a time. Actually, I still use some of those tools. Let me ask a couple of questions. How many of you use AI for coding? VI, sorry, not AI, VI. Oh, good. And how many of you use Emacs? Only 2. Okay, maybe 3 or 4, okay. So those are still my favorite development environment. Actually, you can integrate AI with VI, I believe. But they are very basic from some point of view. What was the next step after those basic editors? Well, some editors, some of us remember Visual Basic, where you had a very simple code completion. So you were typing the name of an object, it recognized the type, and the system was suggesting the name of methods or attributes and so on. What was next? Well, next is what is happening today. We open Visual Studio Code, and we just type a comment explaining what we want to do. Well, it even does more than needed. We try to guess what is my comment, but that was not my comment. As I said, I like to do mining software repository, so this is my frequent example of coding, and it does the rest, basically. That's very simple, and I guess many of you have done the same. Okay. So you have the code here. So, but the point is, how did we get here? How did we reach this? Let's look at how generative AI for coding started. So, first of all, the very first example of generative AI for coding were based on conditional probability. So the idea is that given the last few tokens in your code, those systems were trying to predict the next token. So this is a very simple, this was a very simple idea. It's just a matter of learning n-gram frequencies from a data set. You do not need a large data set, and also the training time is relatively short. At the same time, you don't go very far with this. You can predict maybe the method name or the method parameters, but you will not be able to go beyond 5 or 6 tokens. And this is actually an example I like to do with my students in my class to teach this kind of technology. I take tweets from the current US president as well, all tweets from the president, and then I ask, okay, if the last 2 words were Make America, what will be the next 2 words? And you know already the answer. Okay. I guess you can try with a new data set and see how this has changed over the last couple of months. Maybe it's still the same, maybe it has changed. And this has actually been leveraged quite a bit in some software engineering recommending systems. So we are talking about papers that happened around 2009, 2010. Some of them were quite influential papers. So, for example, this paper won Most Influential Paper Award at ICSI. Next step was the adoption of neural models. Question: how many of you are familiar with encoder-decoder models? All of you. So I can actually skip this slide. That's very good, but so you know exactly what is an encoder-decoder model, what is a transformer architecture, and you also know that those LLM are variant of this encoder-decoder model. Some of them, for instance, like Llama or T5, use both an encoder and a decoder. So basically, it takes the input, it represents it as a context, and then from the context, it produces the output. But some other models only use the encoder. Those models are actually useful when the prediction is relatively simple, but you have complex input. So, for example, if you want to use BERT for doing text classification, like sentiment analysis, you probably don't need an encoder-decoder. You may only use an encoder-only model, whereas models that mainly do generation, like GPT, are decoder-only models. And another thing we have seen over the years is the increase of those models in terms of size. Some of them, I mean, this trend is not always increasing, so we are still seeing some models that are smaller than others, but are still very powerful. So, for example, there have been studies in software engineering showing that relatively small version of DeepSeek or relatively small version of Mistral are pretty good for code generation. So we don't really need several 100 billion parameter models. How was it possible to create those huge models that are able to do pretty much everything? Well, it's a combination of factors. First of all, we do have better hardware, and we know where this hardware is coming from. So this is hardware that was initially conceived for a totally different purpose. So it was hardware designed for computer graphics, video gaming, and so on, because it was capable of doing many simple parallel computation, but then it was first of all leveraged for neural network, where indeed we have several very simple parallel computation, and then there was actually some more specialized hardware. So we shifted from GPU to TPU, which is even more suitable for this kind of technology. So better hardware, but also we have more data. So model of code we are using today work very well because they literally learned from the entire GitHub, from Stack Overflow, and from other forges. Of course, it's not just a matter of better hardware, more data. To train those models, we need time. So especially if you want to train a model from scratch, you need time. Of course, we have seen, as Vittorio was saying, the advances done by DeepSeek in training models with relatively low resources. But in general, we need time, we need money, we need energy. I guess many of you have, again, it's not energy, it's coming back, okay. Just to show you a very simple example, this is the offset for training Llama 2. Actually, a small version of Llama 2, the 13 billion version of Llama 2, which is basically comparable. If you see, this is the offset of a passenger flying from Rome to New York City. So if you multiply, this is more or less comparable to an entire flight from Rome to New York City. So it's quite a lot, and we are talking about a relatively small model. And the other thing is that the training of those models is done in a very smart way. So it combines the supervised training with an unsupervised training. So on the one hand, it just takes data, it masks content, and it trains over data, trying to complete this data. And then this basic training is combined with an additional training that is done with question and answer. So the first part of the training is actually done this way. So you have like a sentence, you take a word or a series of words, you mask them, and you train the model to complete this. So the advantage of this kind of training is that you can just take a huge amount of data, text, code, whatever, and train the model without having labeled data. Then, of course, if you want to train a model that is able to answer questions, you need to do some additional training using the Q&A. It's still going and coming. And that's why some companies like OpenAI pay some people to actually train the model by asking questions, getting answer, and then providing feedback to the model. The other very powerful mechanism that many people are using this day, and it's used quite a lot in software engineering, is the idea of leveraging pre-trained model. So the idea is very simple. If you want to teach math to a child, assume you have two children. One that does not even speak English or Italian or whatsoever language. The other one that at least speak your language. Of course, I guess it's easier to teach math to the child that is at least able to speak the same language as you. So the idea of those models is that we start from models that have some basic knowledge, like a language, and then on top of this knowledge, you can add further knowledge with an additional training of the entire model, or as I will show later, of a part of the model, and this will help creating more specialized models. So for instance, you can have a large code corpus, and you train a model using just unsupervised training to create a so-called pre-trained model of code. I will show you some example in a minute. So models that basically know the syntax of source code written in different programming languages. Then on top of this, you can take this model and specialize the model. So let's assume, for example, we want to create a tool that is able to automatically patch software vulnerability. So the problem is that we do not have a lot of data about software vulnerability patches. So what do we do? First of all, we take a pre-trained model that at least knows the syntax of Java or Python or whatsoever language. And we don't even need to train because there are plenty of those already available. And then we should, first of all, give to the model some basic knowledge about a problem which is relatively similar to the problem we are coping with. So let's assume we want to fix software vulnerability, but we have very few vulnerability data. And our goal is to train the model with a problem that is as similar as possible to vulnerability fix, for which we have enough data. What kind of data would you possibly get to train the model, for which maybe there is more data available, more bigger data set available? Any idea? Well, what can be very similar to vulnerability fix? Just generic bug fix. So at the end, a vulnerability patch is a very specific bug fix. So I teach the model how to fix bugs. And then I further specialize it on how to patch vulnerabilities. So by adding subsequent layers, I create a specialized models while still having very few specific data for the problem I want to solve. And this has been used in different kind of application, including code completion, but also vulnerability patching, code review, program repair, and so on. And as I said, when you have to specialize those models for software development tasks, at least for many tasks, you don't need to start from a very generic model. So if you take a model like Llama or T5, those are generalized models that know languages. They know English, they know French, they know German, some of them even know Italian. But for code-related tasks, it's better to start from other models that are more specialized for code. So, for example, DeepSeek is a specialized model for code, called DeepSeek Coders. There were other models like CodeBERT or CodeT5. At this point, those are kind of obsolete. And there is CodeLlama, and also GitHub has its own code-specialized model, which is called Codex, which is actually different from the one it is using in the chat. Actually, GitHub Copilot is using two models, Codex for code completion and GPT or other models for the chat. So this is the basic technology we use. Now what we need to do, we need to understand what are our expectations for those models and how we can use it in a software development process. And I will tell you some experience coming from our studies, but also from other studies, on how those models could use or also could not be used in software development. Again, every other time it's coming and going. And well, first of all, we did the first study. This study was actually done not many months after ChatGPT was released. So what we did basically, it was like, I believe, when we started data was 6 or 8 months after ChatGPT was released. We mined the entire GitHub for all the possible traces of ChatGPT in commit, pull requests, and issues. We filter out this data set because, of course, there is a lot of noise because of course there were also projects, those traces were not only related to code, discussion in which developers benefited of ChatGPT for code completion, but also there was some code that was, for instance, related to clients of ChatGPT, so false positive. So we cleaned up this code and we did a qualitative analysis to understand how developers of open source projects hosted on GitHub actually leveraged ChatGPT. And this is basically a big overview of what were the categories of tasks for which developers benefit. Those numbers basically reflect the number of commits, issues, and pull requests in our dataset, so you do not even need to care about the numbers, but maybe numbers give an idea of how frequent is each type of application. Of course, it's not surprising that most of the people were using the LLM to implement a feature or to improve their code, but also a lot of people are using it to automatically document the code. So given your code, automatically document it, or even generate README. It's especially popular when you need to generate multilingual documentation. Works very well. But another thing which is very important, and we will go more in detail about learning in a while, is that sometimes programmers prefer to write their own code, but they just use LLM to learn the technology. So I use the LLM to understand how an API works, what could be a possible design for my code, but then I do it by myself, which could be a possibly interesting approach. Other applications were software quality, so generation of tests, but also code review, code refactoring, and also to set up the software development environment. And here you can see an entire taxonomy of all type of tasks that were done using those tools. So for example, you can see, as I said, the internationalization support among the feature improvement, but also different kind of learning, like getting familiar with the code base. So I'm a new programmer in a software system. I want to understand what is this system about, or how to use an API or framework and generate code example for this API and so on. So what was the lesson learned from this study? Well, first of all, there were many other uses still to be investigated. So this was just what happened a few months after the ChatGPT was released. But there is a big question that arose to our mind when we were doing this study. So the commit, the issue, the pull requests we mined were related to developers that were very accurate in documenting their activity, their code. Why? Because they admitted their usage of LLM while coding. I suspect that most of the developers that are using LLM while coding are not documenting it at all, which in my opinion is very bad, because we will be back to that problem in a while, but admitting that a piece of code has been generated is the same as giving attribution to somebody else when you use somebody else's source code in your program. So this is quite important. The other thing we discovered, and I'm also discovering in my course, is that those models are not working very well with very specialized pieces of technology. So my students are using it for the software engineering course. They develop program in Java or Python, not a problem at all. My students from the NLP course, of course, are using it, not a problem at all. When it comes to the video game development course, if you want to do very simple things, very basic things, it does something. When you want to start to create a real video game, there is no help at all. The reason is very simple, is that there is very little data about this kind of software, and this is a problem not only for people developing video games, but every time you go in a domain in which you are using a very specialized technology, don't dream about using those tools to get help, because you will not go very far. This is another study that also provides some feedback on how developers are using this kind of tool, and this also gives a very surprising results. So professional developers like to write their own code, where they leverage this kind of tool, and I admit I am doing the same, is to carry out repetitive tasks. So if you are going to do a task for which you know already it's going to work and it's just repetitive because it's always the same, you don't waste time writing the code. You just let the LLM do, and then you maybe manually check the code. I pretty much do the same. And the last study I'm going to present about this thread is about students. So this is where this is starting from. So the day after LLM were released in, we all started to see discussion among university professors. What we are going to do with our project? Should we ban it from the project? Should we ban it from the universities? And this is nothing new. So if you see this article from Washington Post, this is dated 1986. This is about banning calculators from math programs. So do you see calculators being banned these days from school? No, not at all, it's not possible. So the same is, of course, for LLM. We have to accept that this will be part of our life. Of course, when a kid starts to learn math, they should be able to do math by hand. They should be able to do addition, multiplication. I was even told how to do square root by hand. I don't know about you, but I was able to do square root by hand. Then, of course, for serious things, you start to use calculator. The same applies to LLM. You should be able to do things by hand. And then, of course, to increase productivity, you should be able to use those tools. So the first idea was to forbid things. So this is Roscoe Pickle Train from Mozart. This is 70 movie. Maybe many of you are not familiar because it's too old. Older people maybe are more familiar with this. And yes, as I said, there are controversial studies, because there are studies saying that LLM aid in understanding complex context or becoming more efficient with the coding environment. Also may help you to learn concept and so on. So we did a study. This study actually involved 5 courses. One of them was even from L'Aquila, so it may even be that some of you was involved in this course, I don't know. And in those courses, we let students do different kind of tasks. So not just coding, but you see here all sorts of tasks that software engineers could do. And we actually trained the students to explain how they could do this task. Also with LLM, what was the proper prompt engineering and so on. So from requirement engineering, modeling, architectural analysis, to the more low-level tasks like code generation, but also testing, debugging, and code review. And those were the courses from 4 different universities. So what we learned from this study? Well, those bars indicate the perceived usefulness. So if you see more blue than orange, which this means that the tools were more useful for the task. More orange means the tools were less useful. So it's not surprising that we saw that those tools were less useful for the high-level phases, especially requirement, modeling, and architecture, whereas they were quite useful for very repetitive tasks like documentation or code generation, but also code review. Why? Because, of course, those models have seen less example of what is a good architecture, what is a good design, and especially when you want to do requirement engineering, although there have been many attempts at doing requirement engineering with those tools, if you want to develop something which is competitive, something which is new with respect to what is already on the market, you still need your creativity. Of course, there is a lot of effort in how to apply those models for requirement engineering, but it's still a long road ahead. So, as I said, slightly more useful for code-related tasks, but also many students use those models as learning objects. So instead of learning from Stack Overflow, they started to learn by interacting with the LLM. And this is also an interesting phenomenon because you may, I mean, if you ever look at how forums like Stack Overflow were live 5 or 10 years ago, there was a lot of activity there. Now it's kind of declining. People are using those forums less and less. So it's, I suspect that in a while they may even disappear. The other point we investigated was the interaction challenge. So for some tasks, you ask a question and get the answer. So especially in this case, it's actually easier for the high-level phases, like requirement engineering, because you ask a requirement, maybe you are not lucky, but if you're lucky, that's the requirement. Same for architecture. If you want a sketch of a software architecture, maybe you need to adapt it, but you get it from the scratch. Vice versa, if you want something that actually works, it's more complicated. And this is especially true for tests. Why? Because if you want the model to generate test cases, what's the challenge? You need to provide the proper context. You need to, first of all, give the code that has to be tested. And sometimes it's not just that method or that class, because the test may involve other classes. So it's quite complicated. And also you may want to explain what kind of testing criteria should be followed and how a test should look like. So a few short example approach could be a good one. So providing tests was not very easy for the student, and this was actually a good indication for researchers, because having tools that are able to help developers with prompt engineering for specific tasks will be very valuable. So when you use, even when you use GitHub Copilot, it helps you to complete the code. It gives to the model a good context, because it gives the entire code you are open, all the tabs. But if you want to generate test cases, you have to tell how those test cases should be like. So it's not exactly easy. And as I said, for other tasks, it was relatively easy, like it was for software documentation. So, in conclusion, we learned that the LLM adoption in education is very promising, but it must be carefully pondered in a way that developers and especially students are benefiting from it. And it does not just provide drawbacks. So, just to give another example, to tell another story, there is a colleague of mine that is sending assignments to her algorithms and data structure students. So she teaches algorithm and data structure. And she knows already, because she has used her assignment as prompt for ChatGPT, what will be the solution from ChatGPT. And she knows already that the solution provided by ChatGPT does not have an optimal code complexity. Okay, so it's way suboptimal. And she asked the students to write that code with a given upper bound in terms of big O, and all students failed. Because they tried to use GPT and then they got like quadratic complexity, whereas the task was like linear. So it has to be used with very care. The other thing is that we need to adapt our curriculum. So first of all, so I was program director for bachelor and master some years ago. I guess you were the same. And what I was keeping saying to my colleagues was the following. If you teach something that students can learn from the web or from Stack Overflow, what you teach is not useful at all. What I'm telling today to my colleague, I'm no longer directing the program, I'm directing the PhD now, by the way. But what I'm keeping saying to my colleague, if you teach students what they can already learn from LLM, then you are not useful. You can be replaced by the LLM. And there was somebody tweeting about this a few days ago, about the possibility of replacing the university by those LLM. I'm not telling who put this tweet, but you can easily guess who was this person. That, let's say this was a person that is trying to optimize a given government. So you can guess who was the person who posted this tweet. The other thing, we should properly tell students how to properly use those models, which first of all means prompt engineering. Doing a good course on prompt engineering is very useful. I will go quickly on prompt engineering in a while, but also let students combine manual tasks with the use of LLM and force them to use LLM in a very critical way to understand what are the mistakes, what are the limits, and so on, and understand where they should benefit from those tools and where instead they should just go manual. All right, so these were the promises on using those models for software development. But, well, sometimes what happens? Sometimes we have to solve a problem which is so specialized that using those models out of the box is not sufficient. So, for example, I'm just going to tell some student projects that were developed by my students in the last couple of months. So there was a group that was creating a chatbot to help pilots landing with a flight simulator. So chatbot which was also able to recognize the voice. So you ask, okay, I need to land to this runway. What is the procedure to follow? And the system was able to recognize the question and give instructions showing the cockpit and providing the right procedure. And of course, if you just use an LLM, it's not able to help you because it really depends on the simulator. So what they did, they fine-tuned the model by using the user manual of those simulators, and it worked very well. So how we can customize those models for our needs? So there are different ways of doing it. And of course, one thing to keep in mind is that, as I said before, doing this customization may cost, if you are not careful, a lot of money, a lot of time, a lot of energy. So, and also requires very expensive resources. So there are good alternatives to the training from scratch or to the conventional fine-tuning. So the very first alternative is to be able, first of all, before even thinking of doing of creating a fine-tuned model, of playing a little bit with your model, or properly tuning your model. So the very first thing you should do, and I guess this is something you know already, is to explain to the model, and this is normally done through the system prompt, what should be your role. So what should be the system role, sorry. Whether the system should act like a Python developer or a machine learning expert or somebody else. So This typically helps with getting proper answers. So this is really the basic. The other thing is that you should provide contextual information. So if you want to get an answer which is from a very specific context, you should properly introduce the context to the model. So for example, this is a part of a prompt we were using in a research related to technical debt management and repair using LLM. And we first of all started by explaining what technical debt means. The other thing, and I will show more cases like this, is to provide example of the task. So let's assume, but well, probably for this task is not even needed. I'm using this task because it's a very simple task. Let's assume we want the model to do sentiment analysis. A good way to instruct the model on how to behave is to provide a few examples. So a sentence which is negative, a sentence which is positive, a sentence which is neutral, and then you ask, okay, given this sentence, then classify it, giving the example that I showed you before. And the other thing you can even do is to even specify the format in which you want the output. So if you give proper instruction, those models may work fairly well. This was actually used in software engineering work. This was a work that appeared at ICSI last year. And basically the idea is to use LLM with an architecture which is a chain of thought to understand API misuses. So cases in which API are not properly used. And as you can see, this is what the authors of this work did. So they started from data from GitHub, they extract some rule, and then instead of just asking the LLM to generate misuse rule, they, given the current code, they retrieved the most similar rule from a database they built, and then using subsequent prompts, they were able to generate the misuse rule detection and even the repair action for the misuse. And also in this case, you can see that the authors used a few short examples to help the LLM providing the rule. So before even thinking any kind of fine-tuning, this may just work well for many tasks. Of course, this may not work when you need to add more specialized knowledge to the models. If you want to add more specialized knowledge to the model, there are several possibilities, and there are others that I'm not going to explain because of lack of time. The very first possibility is the fine-tuning we have seen before. So you start from a model that has some knowledge, and then you specialize it by continuing the training or some other knowledge, and then you specialize it again, and then you specialize it again. But this may be challenging because, for example, if you want to fine-tune Llama 3 60 billion, your machine should be able to master Llama 3 60 billion, should be able to train Llama 3 60 billion, which is not doable for many GPU machines some university have. There are, of course, other possibilities. One possibility is to do parameter-efficient fine-tuning. How many of you are familiar with this? Okay, a few of you. So, what is parameter-efficient fine-tuning? And one of the implementation of this is LoRa. Instead of fine-tuning the entire model, you actually add further layers on top of the model, and you only fine-tune those layers. So you create a new layer which is composed of the original model plus additional layers. So your fine-tuning process does not occur on the huge 60 billion model, but it only occurs on the additional layers, which are relatively small, so the fine-tune is in the end doable. Of course, keep in mind this is not the solution of all problems, because when you do inference, you still have to do inference with the entire model, and actually it's even bigger because you have the additional layer, so you still need the power at inference time, but it's still better than nothing. The other architecture you can use, and you can actually combine both of them. My students often combine both architecture, is retrieval augmented generation. I guess this is more familiar for you, right? How many of you know RAG? Most of you, so I'm not going really into the detail, but for those of you that are not familiar, it's a very simple architecture. So let's assume the LLM does not really have the knowledge for which you want to generate a solution. So you combine something that in principle is a very old technology, which is information retrieval. So you have a knowledge base with all your knowledge. You start from your query, and you use your query to retrieve, first of all, some relevant knowledge from the knowledge base. So in principle, you can even use a vector space model, very simple, simple technology, but in most of the cases they are either using BM25 or a transformer-based model, so they use embedding to better retrieve knowledge for the knowledge base. Once you retrieve some knowledge, you use this knowledge as part of the enhanced prompt for the LLM. So you give to the LLM your original query, the context you have retrieved from the knowledge base, and you ask, okay, given this knowledge, generate the solution. And it leverages the context to generate the solution. And this helps you to provide specialized solution even when the LLM does not really have the knowledge. And yet another possibility, as I said, and my students often do this because it's probably the one that works very well, you can combine the last two models. So you can do a parameter efficient fine-tuning of the model, and then you combine it with the RAG, and it actually works very well. All right, so all is beautiful, but there are actually many dangers. And well, since I'm going quite fast, let's calm down a little bit the pace, and I want to see whether there are, okay, in the meantime, it is also taking the rest, whether there are questions or curiosities so far. Don't be shy. Yes?
When you're talking about the fact that LLMs are bad with working with recent technology because they lack context and so on and so on, do you think it's, so your research was in 2023, right? Do you think it changed since then, since the idea of LLM being connected to the internet and being able to, thank you.
Harry, il pulsantino rosso in basso, sotto. Il pulsantino rosso. Tienilo premuto qualche secondo.
Okay, in the meantime, I got the question. So the question is, the very first LLM, and this is an excellent question, okay. Also because I'm going back to this concept you just mentioned of web-based search that some LLM systems do. So let me give to everybody in the room a bit of context. So the very first LLM, and still some LLM today are just models. So you train the model at a given time. So you train the model 1 year ago, and the model, of course, knows whatever it was trained 1 year ago. If there is a new technology that just appeared, the model does not know about this technology. So, for example, if you download the last version of Llama, you install on your machine and you ask to this model, who won the last soccer match on Sunday, it is not able to answer. However, if you ask an online LLM-based assistant who won the last soccer match on Sunday in Milan, it is able to answer because it combines a web search with the DLLM. So it pretty much does what I showed in the previous slide. So it's like a rug-like system, and I'm going to do on this actually for the last problem. So there are two problems, however. So for recent technology, the answer is yes. So some of the problems, like hallucination due to deprecated API, or the LLM not being able to leverage the most recent API, are less of a problem. On the other hand, very specific niche technology is still a problem. So despite the web search, I can tell you that developing video game with LLM is still a challenge, but I can also tell you that even before, developing video game by searching on Stack Overflow was a challenge. So it's still hard to find answer on the web. And so there are pieces of technology for which there is very few data on the web, and LLM are still struggling. I know there are research groups that are, and even companies that are working on how to adapt LLM for they call rare technology, or very infrequent or specialized technology. So domain-specific languages, scientific languages, as I said, video game, but there are many other examples. And let's not forget there are programmers that still need to write COBOL code or Fortran code. I'm not sure how good those models will be to generate COBOL code. So yeah, it's a problem, but there are promises, and I'm going to talk about this related to intellectual property. So other questions? Over there. I guess we need the mic there because it's very far.
Hello. My question is related to prompt engineering and how does it affect the behavior of the large language model. There was one example where you were showing that if you say the language model, for example, ChatGPT, that act as a machine learning engineer and do something, and then versus another prompt where you don't say act as a machine learning engineer, but you ask the language model to perform the same thing. What does it actually change? And how the response is better with when we specify the role and when we don't specify the role.
Okay, so basically the question that was asked is whether or not it's important to specify the system prompt. So let me make a clarification. Typically, in order to specify that so-called the system prompt, you have to interact with the API and specify it in the API. You can specify it from the regular prompt, but it's not clear whether it works well or not. So I have only an anecdotal experience that for some tasks it works well, and other researchers have such an experience. There are papers that show that this seems to work. Of course, my interpretation is that this is because in the supervised part of the training, this is where the model has been trained. But I'm not 100% sure because, of course, I'm not the developer of those models. So there is still a question mark. There was a nice talk at ICSI last year from a person from PyTorch saying that we just don't care about those prompts. So it's really debatable. But at the end of the day, as usual, we just need to experiment.
Come here.
Yeah, another couple of questions, then I will continue.
So my question is that what I've seen is most of the times when you use these models, the solution might not be optimal. It would give you something which is very common and which is working, but it might be the optimal, and those optimal solutions can be found based on your own previous experiences and also reading the documentation, and based on how fundamentally you know the problem statement or the entire scenario. So what do you think about that?
So, not sure I understood correctly the question. The question is, you use those models, you get something that is not optimal, and then what you do?
Yeah, so they're working fine, but they might not be optimal. So what do you think?
So it really depends on what is your goal. If your as I said, if your goal is to learn a completely new technology or start a task from scratch, even getting something non-optimal can be a good solution. On the other hand, if you have to do something like writing an optimized piece of code, I was referring to the algorithm and data structure task, then it's probably not the best solution. On the other hand, there is the other face of the medal in which you write your code and you ask the LLM to optimize it. So sometimes it's even the LLM able to optimize it. And there is something that I did not even mention, which is something new and emerging, is the multi-agent scenario in which you can put together multiple LLM-based agents, asking each of them to optimize the other one code and to do a sort of adversarial optimization of the generated code.
Thank you.
Last question, and then maybe I will continue.
Yeah. I have a question regarding the fine-tuning. So what happens if we have a downstream task, but data doesn't exist, or it's simply very expensive to collect? Do we have other alternatives instead of fine-tuning? Because we probably can't do that without having data.
So, as I said, if you have a few data, you can try with the transfer learning. So think about the most similar problem for which you have data, and fine-tune your model for the most similar problem. And then, at that point, if you do not have data at all, try with a few short examples. That's the process. So transfer learning and few short examples could be the solution. So let's, very last, okay. One more.
Okay, so I have a rather obvious question. You mentioned that some tasks are LLM can do that and some are still human intensive. So I was just wondering that what do you think is the modern way of, let's say, approaching a problem, let's say a software problem, because there's this fine line. Sometimes we are delegating tasks to LLM a lot, but sometimes we're doing too obvious of a task that could be done for instance by a GPT or another LLM. So I'm just trying to understand that what's your opinion to a modern way of approaching any software problem.
Sorry, can you repeat the last
So my entire question is, how do you think is the modern way of approaching a software problem with the availability of all these LLMs, GPTs, and all these stuff?
Yeah, I guess I don't have an answer for this because it's too complicated. I mean, it really depends on the type of task. There is no single solution. I mean, different tasks have a totally different way of being approached. I mean, code generation, straightforward. Testing is super challenging because you need a lot of context, you need a lot of rework. Code review, you need a lot of rework. So, I mean, my suggestion is do not think about using the same approach for all the problems and for all the domains. Okay. Try to customize it and interact multiple times and experiment multiple ways of doing it. Okay. Okay, let me continue, then I will try to leave some minutes after. So, those are some dangers: lack of trust, hallucination, and intellectual property problems. And I will mainly focus on the last one. So, why lack of trust? So, I was giving a talk on this topic and somebody asked me, okay, but you're talking about lack of trust in the sense that people may not trust what AI has generated. But people are still using things from the web, and people trust whatever is available on the web. So somebody told me, okay, there is no difference. Well, that's not true. There is a huge difference. The difference is that when you reuse something from GitHub or from Stack Overflow, you know from which project the code is coming from. You know whether it's a well-reputed project, a well-reputed owner. You know who has posted the solution on Stack Overflow. You see the comments on Stack Overflow. You see the badges, the upvote. You have all sorts of reputation indication. You don't have those when you use LLM. So at this point, one important thing is to, and this is also an answer to the colleague that was asking before, how to interact with this LLM. Probably these days we will go, our future will be to write less and less code and to review more and more code which is generated. So we should learn how to review generated code, and at the same time maybe the LLM will review our code. So it's a sort of chicken and egg problem. And as I said, the multi-agent approach is also possible, so having multiple LLM interacting with each other. The other problem is hallucination. We were already discussing this, and of course one problem is related to technology that the LLM has not seen yet. But the other problem is that LLM oftentimes tend to get confused. So when I started my talk, I showed you an example of GitHub API. I want to generate list of commits from GitHub. So this really happened to me. We were working on analyzing the GitHub dependency graph. So you know on the GitHub there is a dependency graph that shows dependence from one project to the others, but also the list of projects that depend on a given project. So I was lazy that day, and I asked Copilot, okay, can you please write me a piece of code to download the list of dependencies from GitHub, a given project on GitHub. And I knew already that for this task, the only way to achieve this task is to implement a web scraper. So to go on the page and scrape the page. There is no other way of doing this. And in a second, I will show what GitHub did. So this was the task, and this was the solution. Basically, if you see the solution, GitHub Copilot was suggesting this GitHub API accessing dependence. A pity, because this API does not exist. So it was trying to do something very similar to the same API I was using for commits as for dependencies, but there is no such API. So, why hallucination? As I said, sometimes problem related to deprecated or non-existent libraries. In this case, it's not existent, so it's not really related to updating the model. And sometimes lack of context. So, for example, assuming you want to ask help to improve or to generate the graphical user interface for your project. So you should probably tell the model what kind of technology are you using. Otherwise, it will suggest part of the GUI using a technology that you are actually not using, a library different from the one you were using, and your program will become a mess. Okay, now let's go to my favorite part, which is legal issues. I really love this part. This is important, and some of you may have already seen some lawsuit between OpenAI and some newspapers, because OpenAI generated text from newspapers, or even novels from existing books, so all copyrighted documents. Well, some people say, well, but you know, it's not a problem, because our LLM were trained with permissive code, so we excluded GPL code. Well, there are two problems. First of all, that's certainly not true. LLM were trained with the GPL code. Second, even for code that has been trained with permissive license, if you are creating a derivative work from, say, MIT or Apache project, and you fail to provide attribution to the original authors, you're violating the MIT or Apache license. And the LLM are not very helpful on that. So, just to show an example, I'm using R, which is a statistical tool for my stats. And I asked R to generate a piece of example for a linear mixed effect model, which is done using this LME4 library. So it generated the code, not a big deal because it's a very simple code. And then I tried to ask, okay, what is the license of this code? And well, the answer I got from ChatGPT was, okay, this is a CC BY license. No, it's not CC BY because this library is GPL. So actually, if I create a derivative work with this library, I must redistribute it with the GPL, period. So there is already relevant work showing that those LLM are infringing many licenses. And in addition to that, we did a study. This study will be presented at MSR in Ottawa in April on the ability of LLM to provide links. And this is related to the question I was asked before about LLM ability to search. So let's do an example. If I ask LLM to implement a given task like FFT, it generates my Python code, whatever. So the code at this point is not really relevant. But at this point, what I do, I ask to get some sources. And unfortunately, I get very, very generic sources. So a SciPy page, which is not related to generated code, and a simple Wikipedia page about the fast Fourier transform. So those sources are not very helpful to help me give proper attribution to the code. So we did a study in which we analyzed the extent to which, if we ask the LLM after it generates code to provide links that are related to that code, to what extent those links are valuable. And you will see results are pretty surprising. So first of all, we did this study with Gemini and Bing Copilot. So you may think we are crazy because those are for sure not the most used tools for code generation. But the reason why we did this is that at that point, when we started the study, those were the only tools that were able to do what the colleague was referring before, so to do the search on the web. Now, many others are also doing this, but at that point, those were the only ones. So what we did, we took a benchmark which is quite used in those code generation experiments, and we used those queries in 6 different programming languages to ask Bing Copilot and Gemini to generate the code and to also provide us links related to the code. And we analyzed those links by combining a manual analysis, so we open each link and try to understand whether the code in the link was actually the same that was generated, actually same structure, even sometimes same identifiers, same literals, or were links that were totally irrelevant. And we also complemented this with some automated analysis with the clone detection. Why we use those tools? Because those tools implement a RAG-like architecture we were discussing before. So some LLM-based tools actually are not just models, they also search on the web. So these days, if you ask ChatGPT to get latest news, it is able to provide, because it's search on the web. So these days, you can actually repeat the same study using ChatGPT or even with DeepSeek, because they also search on the web. But, well, it's basically the same, at least between Bing Copilot and GitHub Copilot or ChatGPT is basically the same model, which is GPT in this case. So that's why we choose those tools. Let's give some figures. How many links did the model provide? So big variation. So Bing Copilot, for each generated code, provided us between 3 and 18 links, with a median of 4 to 5, depending on the language. Gemini, way less links, between 1 and 8, median 2 or 3. Now some of us may be thinking, okay, but if you really need to understand where this code is coming from, you can do a very simple thing. You take the same query and you search on the web, and you probably get the same code. Well, we experimented that, and guess what? Between the links provided by the LLM and the link got from the first page of Google or Bing on the web, almost zero overlap. So they search on the web, but apparently they do it in a very different way than we do. Maybe using embedding or more advanced technology. So, very first information, which is quite interesting. If you see, Gemini is not working very well. No surprise. Bing Copilot, you see, in many cases, there is, for many queries, there is at least one link which is actually providing the same code that was generated. The problem is that you have to go to up to 18 links and you have to browse many pages. So it's a lot of work. In fact, we are developing a tool to help software engineering in better providing sources. But in many cases, at least I would say almost always in the majority of cases, the solution is there. And what kind of links did this model provide? In most of the cases, those were the cases in which the code was on a Q&A forum, like Stack Overflow. So if the generated code was learned from Stack Overflow, it provided a link. Sometimes it even provided code directly from GitHub. In many cases from tutorials, and we had very good evidence that the code was there. Less of the case was official documentation of code example because, almost always those tools provided us with links to the official documentation. So if you try, you will always get official documentation, Wikipedia, but those are completely useless if you want to get the relevant link. So let me just show one qualitative example. So I asked the system to give a Python code snippet to output an HTML file, to convert the text to HTML. And this is the code I got from GPT. So if you see this code, you may already figure out that this code is not completely generated, it's actually learned from somewhere. Look. And we asked it to provide links, and of course, among the links, there were links where the actual code was. So this is the actual code, and this is the generated code. So you see how big the problem. We are actually, by using those models, we are actually reusing the code. As I said, now this is getting better because ChatGPT is able to do this. If you use DeepSeek chat, not the API, but the chat, which is this day disabled in Italy, but I guess it will be enabled in a while, as it happened to ChatGPT in the past. Or even if you use GitHub Copilot chat, you will be able to do this. Actually, okay, so this is about this licensing issue, and I believe this is really a big problem because without getting attribution, you really don't know the extent to which you should redistribute the code. Now, before going to the last part of my talk, I want to ask you a question. If I include in my project a piece of code for which I asked help to the LLM, who are the owners of this code? I say the owners, not the owner, because I already believe what part of the answer should be. Any suggestion? So, the last part of the chain is me. I adapt the code so I can take part of the ownership, sure. So I put my name, fine, but it's not just me. I should give credit to the LLM, and I should. If you carefully read the terms of services of those LLM, they ask you to provide credit. Nobody does it. They also tell you what to do, what not to do, by the way. Nobody does it. And then, the original code. We should provide attribution to the author of the original code. So there is at least a chain of 3. Yes?
As far as I know, according to current law, content generated by LLM is not copyrighted by anyone, right? So that means that then probably you are the only person to blame, at least in my opinion, right?
Yes.
This is opinion.
No, you're totally right.
In my opinion, the person who was the last to adopt the code is taking the entire blame, because according to the law, LLM has no copyright, the company has no copyright. So if you're talking from legal standpoint, if you're talking from moral standpoint, that's another question.
No, I totally agree with you. So the point is that up to now, the law says that whatever is generated is not copyright. But I believe, I may be wrong, but I believe it's a matter of time, because this is so big and this is so evident that I really doubt the law can stay the same. I did not show other example, but this is something I show to my undergrad students. You can easily generate copyrighted images. I can easily generate Mario Bros, or I can easily generate a Ferrari, and this is all copyrighted material. According to the current law, this is almost anarchy, but I don't believe this can stay forever like in this way. So something should probably happen to this respect. The last part of my talk will be about machine learning model transparency. So we'll put ourselves from a slightly different perspective, not from those that want to use LLM to generate code, but from those that want to use the model in their system. And, we are discussing it many times. We are probably seeing this in many cases. Sometimes we are very scared about using those models as API, especially for critical tasks, because we don't want to send our data to OpenAI, or we don't want to send our data to DeepSeek. As I said before, DeepSeek is now locked in Italy, and even in US, something is happening with DeepSeek, I believe. So many people prefer to use models that they can download from forges and use them. One of those forges, probably the most popular of those forges, is Hugging Face. I guess all of you know Hugging Face, so I don't need to explain what Hugging Face is. And many people, you know how people call those models? They call open source models. How many of you did hear this term, open source models, as machine learning models refer to models that are on Hugging Face or TensorFlow? A few of you, yeah. They say those are open, even open source. Well, I know what open source code is. I have found out what an open source model is. So, what is Hugging Face, you know already. What we did in our study, we look at those models in terms of dataset availability, licensing, even now we are looking at term of uses, and bias documentation, the extent to which bias is documented. Well, what we found is those models are so-called open source, but they are not so transparent. Only 32% of them specify a license. Okay, some of you are now thinking, okay, and what? Who cares about license? So, let me ask you a question. If there is some source code on GitHub, and this source code is not licensed, what you can do with this source code? So, he's saying anything. How many of you say anything? Only you. So let's ask, so there are two answers. First question is, I can do anything I want with this code because there is no license. Second possible answer is, I cannot do anything with this code. How many of you say, I can do anything? So 2, 3, 4. How many of you say, I cannot do anything? I can do nothing. Okay, the rest of you are kind of... So the point is that you cannot do anything. So this code is copyrighted by the authors. So if you want to do something with this code, you have to ask permission to the author. So the same applies for models. This was why it was like 10 years ago GitHub realized that 75% of the code on GitHub was not licensed. And they started to better advertise license. You know, when you create a project on GitHub, it suggests you, okay, create a license. For a model, the situation is worse. And the other part is that only 14% of the model declare a data set. So they call themselves open source, but at the end of the day, they are arrays of coefficients. We don't know how they have been trained. About license, there are interesting things because there are some ML-specific licenses. Those licenses are pretty interesting. The most recent one is the one from Llama, because not only they determine how you should redistribute the code, or the model, sorry, whether you can integrate the model with the code with the restrictive or permissive license, whether you can use it in a commercial product. But those licenses also tell you how you can and how you cannot use the model. So they forbid unethical usage. So for usage, for instance, for violent content generation, for racism, for even, for example, Llama forbid the use of the system to develop safety critical system because it's not trustable for that. It's not conceivable for that. And in terms of license, it's curious that we found, by analyzing all those models on Hugging Face and by mining all the clients of those projects on GitHub, we found over 700 license violations. So, for instance, there were Apache projects that were using GPL models. So, people are really not aware that those models are like source code. They have a license, and this license should be fulfilled. We also look at bias. I'm not going into detail because of the time, but this is just a map of all possible bias. And many of those models document bias. There is different kind of bias related to inappropriate context, speech bias, or personal or social bias, and so on. So, for example, you see, this is GPT-2, which document the fact that it has a gender and race bias because it tends to produce a different kind of job for white and black or for male and female. Or, for example, there are some speech recognition models or speech generation models that are biased and are not able to recognize voice from people with speech disorder, with foreign accent. So this is another type of bias. So in a way, some of those models also document bias. So why this matter? Why is this transparency important and how can we do it better? I'm almost over, by the way. So, some of you have heard about this. So this was an executive order released in 21 by former President Biden of US, saying that any software for US public administration should contain a software bill of material. How many of you know what a software bill of material is? Okay, you see, the problem is big because almost nobody knows. This is huge. So, what is a software bill of material? So, it is very similar to what I'm showing in this slide. So, when you buy food, you have ingredients because especially if you imagine you have some allergy, you need to know whether this food can be dangerous for you. Or if you buy a car, all the elements of your car are traced. So if there is a failing brake in your car, in my car, Volkswagen will mail me and say, okay, look, the brake in your car is failing, we need to replace it. So the same should happen for code. So software bill of material are basically inventories of all the elements that are contained in the code. Actually, if you go on GitHub, on the dependency graph page of GitHub, you can actually generate the SBOM for any project hosted on GitHub, including your own project, especially if the project is using package managers, otherwise it's not able to do it. And there are different formats for this. So this is the SPDX, which is the oldest format coming from Linux Software Foundation. There is another format called CycloneDX. So it's an inventory of whatever is contained in the code. Now the problem is that nowadays those inventory are very simple. They are basically lists of packages on which the software depends, with their license, with their hash code. But software is more than packages. You can have code snippets that are often not documented here. So if you use a code snippet, it's not here. But also we have models. And not only this was enforced by US law, also in Europe we have this European Union AI Act, which in a way promotes ethical and safe usage of AI. And as I said before, unfortunately, this is not always documented by models. We analyzed the top 400 models on Hugging Face, and only 10% have explicit terms of uses about this. Model transparency, I show you some pictures, very low. And copyright fulfillment, I already showed that from the point of view of using models, people do not care. And from the point of view of generating code, based on the discussion we had, I believe we will soon have a big law gap, a big gap in current jurisdiction. And so concerning models, what I believe is that LLM alone are not sufficient. Those LLM should be augmented also with information about models. So if we use libraries, our code should be documented with all the libraries we use. But if we also include AI models in our code, we should document what are the models we use, how they have been trained. So if you use a tool which uses AI, you may want to know where the AI of this tool has been trained, in order to understand whether you can trust it or not. Otherwise, it's going to be dangerous, especially if you use it for a serious task. So transparency for AI is as important as transparency for the rest of code. Final takeaway of my talk. So GenAI is there. We cannot ignore it. However, it may or may not be useful. It depends on the task. And there are some key challenges related to trust, privacy, and legal issues. Last but not least, we are so happy about the availability of all those open source models, but at the end of the day, they are not so open. And basically, this summarizes and concludes my talk. Thank you. A few minutes for additional questions, especially for the last one.
I actually want to talk not about the last part, but about the first part. You started from the evolution of like IDE and the software for developers. So I want to ask maybe a little bit of general question, but what do you think is going to be the next step? Is something like Unreal Engine blueprints, no-code solutions going to become more prevalent in your opinion with the use of LLMs, or what is the future of software developer tools?
Okay, so the question is about the future of a software LLM environment. Sorry, there was a little bit of Darth Vader effect, but I hope I understood correctly. So I believe the next challenge to be covered with is to master complex systems. So those systems are getting very good to develop small pieces, but where the human is still needed is to put them together, is to govern the process. Next step will be this, to govern the entire process and to master the development of complex software systems. Then we can change job, probably, or maybe not.
Okay, so at one point you mentioned about the code debt situation in where you said that you need to ask GPT that don't add code debt, right? So like code debt, you mentioned that it sometimes gives very basic solution. We want something that can be running in a longer term, right? So like, how do you think we can tell an LLM that what are the parameters of code debt? Because what I assume is that when you do such thing, it will just overcomplicate things. Because like personally, what I do is like I try to get a simplified solution from an LLM, and then I try to build it on like myself based on my logics or something.
Well, I mean, if you, with a proper prompt, sometimes you can get to the solution. The example I was making is the example of lazy students that certainly don't do proper prompt engineering out of the proper big goal for that code. But with proper prompt engineering, assuming the model has seen optimized code, it may work. Otherwise, we need to combine with other things. The other thing, I believe, and this also is a follow-up to the previous question, how should be a system in future? I believe a system in future that help developers should combine those LLM with conventional systems. So imagine a system that generates and then something more conventional that does performance analysis and then feedback to the LLM.
Testing. So as far as I know, retrieval augmented generation have like two main kind of implementations. Like one is sequence to sequence, one is token based. Sequence to sequence RAGs are usually more easy to cite compared to the token based because in those cases we're finding the subsequences. So like I've been going through your research paper for the code-based thing, and I'm assuming they're like, because the models are trained more token-oriented wise, they are focusing solely on the token-based RAG. But like, did you do any extensive research on whether like the performance of merging sequence to sequence along with token-based RAG, because you know we can add multiple layers of pre-querying and like post-processing in advanced form of RAGs, right? So it's somewhat possible to create a loop to have like both kind of RAGs in a system. And do you think it can optimize the like citation or referencing pattern for suppose this kind of things in case the model hallucinates the references?
Okay, so basically the question is whether like sequence to sequence or maybe RAG can also optimize the, can provide a solution to the provenance problem, the reference problem?
It's usually easier for sequence to sequence RAG to properly reference
the problem I see so far is that we are starting from models that are not trained that way.
That was also one of my questions, that it's possible to include like an embedding.
Yeah, probably,
like
yes. The point is that we may, I mean, if you think this as a researcher perspective, it will be very expensive to augment those models with all this information. And, well, should the big players that create those models be interested to do that, I believe that it is technically possible.
Okay, that's like like, how can I say, a good thing. I'll try and see whether it's possible in the future.
No more question.
Let's thank Max again. So he will be with us now at the coffee break, at the lunch. So if you have any other question, feel free. For those of you that have problems to get connected, I have some codes, okay, some login and password. 5 minutes before we restart, please come to me here and I'll give you the login and password for those that couldn't get access through EduRoam, okay? Now coffee break is downstairs, we have 30 minutes and then we come back for the next seminar. So we have now a presentation from Istituto Zooprofilattico Sperimentale, which is a public health institute from this region and Molise, right?
Yes.
And also for Italy. So it supports Italy in activities related to public health, okay? So they will tell more, and they use machine learning, and they will tell their experience in using, in their projects. I wanted also them to come because they also have chances for activities related to thesis or other activities. So it can be also an input for a number of you. Please.
Hello, good morning. My name is Adriano Di Pasquale. I'm a computer scientist. Took my master's degree and PhD here in L'Aquila, so thanks to you, Henry, for this invitation. It's always very nice to be here for me. Since some years, I'm working in a specific area. It's called the bioinformatics. Who knows what is bioinformatics? Please raise your hand. Okay. Who has the possibility to work in the area of bioinformatics? Please raise your hand. Good. Okay. Good. Well, very well. Here we're talking about what is bioinformatics and how we use it here in a specific bioinformatics platform called GEMPAT. I explain what is it. In the Italian national programs and projects and international settings. I've prepared some slides and some interaction with you to let you better understand what does not remember or does not know at all what is exactly the whole genome sequencing on microorganisms. I have to repeat some things that I'm pretty sure that you already did something in high school, but I remember as a computer scientist that when I start to re-understand, this part was a problem for me. I don't know for you, you are younger than me, so for sure it's easier. So we have some recap of the bioinformatics, what is the platform, and what is genomic surveillance. And the machine learning on WGS data, very different settings with respect to all the other things I always listen nowadays, like image recognition or LLM. This is different topics. Oh, please, can you remember what is a DNA? I'm sure that in high school you have already studied this one. Please raise an hand who knows what is a DNA. Okay, rise, come on. Okay. You should know, for what the people that didn't raise then, that DNA, all the organisms has a DNA inside. And the DNA is a code, a biological code. Sometimes they say it's a God code for you, for the life. Is made by 4 letters, okay? A, T, C, G, okay? That are combined together to have the so-called DNA strain. In the central dogma of molecular biology, it is important to remember that from DNA, we extract through a transcription activity a piece of the whole code. It is called RNA, and this RNA is used to produce amino acids and then proteins that is made by amino acids. I hope that this recap is clear for you. The proteins are the real part of the life. It is the part that constitutes our skins, cells, whatever. All the need for our cells is made by proteins. So we have a big code called DNA. We have small pieces of code extracted sometimes, and we have the report, what is produced by this transcription. In the translation, we have the amino acids and then the proteins. Can you have some metaphor in your world of what is happening here? Please think to, I don't know, raise an hand who has some metaphor of this situation. Think computer scientist, I mean. What is happening here? No one? Please, raise an hand. Suppose to have a SOA architecture, service-oriented architecture. What could be this one? No one? No raise a hand? Yes, sure. What does look like this one? I have no idea. Suppose that this could be a database. Suppose the DNA, an int. Suppose the DNA is a database. What is happening here? What could be the RNA? Just try to. It's just a fancy. Yes, please. Good. And what is the protein? No data entry. Data results, the data sets. So, yes, we can imagine it. The DNA is in a metaphor, could be the database of all the information inside the database. And whenever one asks for something, is asking for a piece of these things, okay, a query, and whenever the query is running, some data set arrives to you, and you can do with something this. This is a metaphor. But because I'm from Abruzzo, I am from another city of Abruzzo, we are always talking about food. I'm sorry. My metaphor, oh yes, this was your metaphor, sorry. But my metaphor is like a restaurant, okay? You can imagine the DNA like the whole receipt, the menus of the restaurant, okay? And whenever there is the transcription, it's because the waiters arrive to you and ask for something. You ask for some pieces of that menu. You don't want all the menu because too much. Just one of the dishes, okay? And this receipt is brought to the cooker. And the part of the translation is the cooking. And what is the proteins outside arriving to you is exactly the dish that you ordered. So this is one of the things that you have to think about this. I'm sorry to be too long, but maybe sometime we use this time to not to always talk about LLM, etc., but just to change a bit the point of view, okay? In this point of view, what do you think that it is the same in real life, for cells, for microorganisms, and so on? So, do you think that whenever you look for the menu, okay, is the cooker able to cook all the receipt of the menu, right? Do you think in an evening, is it possible that the cooker is cooking all the dishes of the menu? What do you think about? Could be or not could be? Please. Sorry? Could be. But in general, yes, you're right. But in general, it's not sure that even if you see in the menu some receipts, it is not sure that in a given point in time that recipe will be cooked, okay? Again, from the other point of view, if you see on the DNA some information, some coding part, it's not sure that that organism always use that part of code. For instance, my mother has had blue eyes. I have not blue eyes. But from genetic theory, etc., I have in my menu the receipt to produce blue eyes. But I'm not have blue eyes. So whenever my cooker cooks, does not create blue eyes. It is important in the microorganism settings. You can see from the DNA that this microorganism, it is always for all organisms, of course, can do something, but in practice, in the reality, cannot do everything. Sorry for this part, but it's important to try to understand what is possible to read and to do with the code that you read in the real life, in real organisms. So all the organisms are live actions and are made by DNA, and the DNA has these 4 codes, ATCG. These ones are called the nucleotide NTs here. You should know, again, you knew from your high school, that in the amino acids are made, there is a mapping between a tripole of the nucleotide and the amino acids. Okay? We are interested to the amino acids because connecting the amino acid, you get the proteins, and the proteins means the cellular membrane for antibiotic resistance in microorganisms, for any kind of things you're doing. So we have a 64 combination because of triples of 4 elements, but 21 are the amino acids. So there are some amino acids that are repeating, okay? Like in this case, we have the G, C, and then G, A, C, T brings to have the amino acid A, okay? So there are some of more than one triples brings to the same amino acids. Then what can we read among the sequences? The sequences are the DNA, the sequence of the DNA made by nucleotides, and you should understand that there are specific triples that brings to have an amino acid that is called start, like M. ATG means start codon. And there are specific stop codon, like in this case, that tell you to your DNA code, this is the starting point, this is the stopping point. For what? For create the proteins. This is a piece of code. You can imagine that the rest is like a RAM, comments on your code, but the real code is there. Your code starts from the start and stop. There are specific enzymes in your body and your mind that says, okay, whenever you see the start codon attach, start the transcription. And whenever you arrive to the stop, okay, stop and remove the RNA. The RNA goes in another part called the ribosome, and the production of the protein can start. For us, these slides need to us to understand how is the source code we are trying to analyze. Okay, we have nucleotide, okay, we have amino acid, but we have to understand that we have pieces of DNA called it's called open reading frames, but to simplify, it's the genes. These are the part of proteins that allows us to have blue eyes, brown eyes, black hairs, and so on, okay? So whenever you see the sequence of the DNA, there are specific parts that are called genes. And we understand there are specific parts because there is a start codon and a stop codon, okay? Recap. We can see a DNA in several ways, just by nucleotide sequences, just by triples leading to amino acid, or by genes. It's a different view of the DNA. Hope that is important because then we can do different things with this information. Okay, let's go on. What happened it was very difficult in the past to produce the reading of the DNA. You can imagine that for producing a human body, I don't know if you remember the genome project took in 90s almost 10 years and cost millions of dollars. Nowadays, if you want to sequence your DNA, costs 1,000 euros and takes less than 1 day. Just to understand why, because in the first years of 2000, there is the next generation sequences. There is a specific new technology. Now we have the several level of this technology, but this technology changed completely the production of DNA. The reading of the DNA and the production of the sequencing. It's important to understand how it works. Whenever you have the DNA, here we have the biological sample, suppose an isolate, we can take the DNA from these biological samples. And then we have the fragmentation of genomic DNA. There are some additional things, but the concept is we are dividing the DNA in different parts and then reattaching, trying to do like a puzzle, puzzle game, to understand what is the original DNA sequence. Sorry, I guess was something here and it's not. It is important because with this technology we can do that. We cannot read like a book the entire sequence in one shot. It's impossible. You can read in some way. Take this technology like our possibility to take the picture to the DNA sequences. It's not so easy, like please a face, picture. It's not this simple. There are several passages, and in each passages we need to break the DNA in several parts, read these single reads, it's called exactly reads, and then try to reassemble together in a puzzle-style game, finding the overlapping, to reconstruct the DNA. How long are these DNA? Okay, this is an idea of dimensions. Again, we are talking mainly in our institute about microorganisms, but there are also other institutes working with human cells or animal cells. But just for you to have an idea, the virus is this dimension compared to bacteria, and the bacteria is this one compared to an animal cell, like a human cell. Okay? And this is for the dimensions. And for the DNA length, we are talking about the order of kilobases that we can take as kilobyte, just to simplify the things. Bacteria as of the order of megabyte, million of bases, while eukaryotes like humans are gigabytes. Okay, how are good our photograph to take the picture of this DNA? We understood that we cannot read in one shot. How is working? It's working this way. The real reads that we can take of this entire DNA is of the order of hundreds of bases. The possibility to read is not, I cannot read the whole 1 megabyte of DNA in one shot. I'm just able to read several, but millions of short reads. It's called short reads. Millions and millions of short reads, and so the working that one of the part of the bioinformatics tools has to do is to reconstruct it. To reconstruct is exactly the puzzle game, but with millions of pieces. To try to this is a very simple sequence. a viruses of the order of kbase. This is the length of the reads coming outside from the sequencer. You can imagine for bacteria and for human. So it's a big effort to have the so-called assembly. Try assembly all the reads, try to reconstruct the DNA. This is one of the main topics of these things. Then we have the short reads. Again, as I tell you, this is what exactly I said right now. We have the DNA, we have the already broken parts, the short reads, and the attempt to reconstruct this one. And then we have the long reads. Long reads is a new technology where you have longer reads than the shorter one, and you can imagine that it's much more simpler to reconstruct the DNA, but at the moment, this very useful technology is very, very expensive, and in some cases not so accurate. This is what is more or less the evolution of this technology. The older one is the Sanger sequencing. The Sanger sequencing was in the 90s. He can take almost 1,000 length for reads, but he's very, very slow and very also expensive in producing the sequences. Okay, it can take 800, 900 of reads, but it's very slow. Nowadays, we are talking about this sequence, the Illumina ones, that are shorter, but can produce gigabytes of reads. So it's possible to do that overlapping I told you. This one are the new technology, where you can see that it can arrive more than 10,000 bases, but absolutely much more expensive, and in some case with the low quality of the reads. This is the idea. So again, what we are trying to do is exactly the puzzle game. Okay, this is the real. Suppose this is the real microorganism. Okay, the face now is microorganism. This cutting of the DNA and things is like having small pieces, and the software needs to reconstruct it. Sometimes with holes, because it's not sure that we are able to capture all the sequences. Okay. Okay. Now, if you agree, I would like to provide you a bit of interaction. If you can, I saw a lot of you, many of you with the laptops, and also with I understood that it's also working with the mobile phone. Please, can you follow this link? Following this link, you will land exactly on this presentation. And from this presentation, you can follow these links, and maybe we can have some interaction. Because what I'd like to let you test is exactly the assembly procedure. That is, try to understand what is the working behind. Is something a bit fun, of course, and we will try to have some interaction. Have all of you copied this link? Can I switch? No one problem? Can I switch? Okay. Okay. This link leads to the presentation. Then arriving to this one, where is the link? I can just follow this. Okay, and I'm arriving to an exercise. You can copy this file in your own, and I just open now. You can, if you are with a laptop, you can do open with Draw.io, but I saw that also possible with the mobile phone. So you can take If you want, you can download, you can pass to your drive, whatever, and just open. And okay, you got the first link, good. Have you had the possibility to follow the second link? Okay, I saw someone. I'm seeing, I saw someone that is going around here, more than one. Okay. You can also copy this file and work with your copy. No. Okay. Well, someone is arriving, someone is landing on this document, very nice. This slide is just for let you understand if I'm able. No, I'm blocked. I'm blocked. Okay, here. Let me see. No, I'm blocked. Okay. Okay. Okay, this one I'm a bit blocked. Oh yes, I can move this one. This one is a slide that show you exactly the dimension, as I said before. These are, if you consider that this is, I don't know if I moved or some of you have moved this one. If you consider this as the read length, this one in comparison is the virus length, and this one is in comparison a bacteria's length. I'm not able for the moment to zoom out easily, but if you just to have an idea, no, it's not possible. Sorry. Okay, just this way, I can. Just to have an idea of how big is the bacteria's, and we have to compare. And this one is again the cloud of, is normally called like this. It's a cloud of short reads trying to attach to the virus sequence and to understand which are the virus sequence. If you agree, you can do this one and can raise an hand who is the first one that tell me what is this virus. Okay, it's not a virus, but it's like, please, you can do this. You can even move if you want. Someone that already understood can raise an hand. I think that someone moves and then someone other moves in another.
There's some a bit of.
Well, this is it's interesting because it's a parallel programming on trying to have an assembly of a DNA.
They are fighting themselves.
Sorry?
They are fighting.
Yeah, they are fighting. Like it's normal to have in parallel programming. You are fighting for the resource. Oh, come on, you're right. Come on. Okay. Who's this guy? Who's this guy? No one understood? Okay. Okay, you got it, but you are removing. Okay, you are trying with several things. Good. Good. Okay. You got it. Take in consideration that I have a more complicated task to let you do. So please download it because I think that with this, how to say, forced interaction, I don't know, but we'll see. I like it with the parallel tasking, working on this. Okay, I think you got it as a pirate. Okay, with this one is we understood that the DNA we are under is like more or less a pirate. Okay. Please. Now, what we're trying to do is this. What you did is assembly. You reconstructed the DNA from the short reads received from the sequencer, okay? You just receive sequencer and you put, we can say we have two different type of assembly. The de novo assembly and the mapping. In the mapping, we have a reference. It is, we know that all these reads should be close related to this reference. I provide you, one provides a reference, and the activity is to try to map these short reads on this DNA. The other one is no reference, de novo assembly, trying to just see the overlapping of the paces and try to understand how can create these things. Now, as you can imagine, with the de novo assembly, I'm able to catch the specificity of the microorganisms that I'm under analysis, while with the mapping, I'm imposing some reference, again, some things. May I go here? And please tell me what is inside here. I think that is much more. If you want, you can do this, so I can. Again, someone who can understand, at the moment that can understand what is inside, please raise an hand. I can say that, you, come, go. Sorry? Okay, there is a unicorn inside, but there is not only a unicorn. Haha. It would be so easy. There is a unicorn, okay. This is a case that is a bit more complicated than usual, that is contamination. Contamination means that inside my biological sample, there is not only one microorganism. Sorry? Your assembly procedure works well, but it's not. This face is very, very famous, so human face is too low. As someone has the name of this human face, it's very famous. Come on, Homer Simpson, okay. Okay, someone understood whenever appears this one, I guess, okay? Okay, but as soon as these specific parts of Homer Simpson appeared, you didn't understand it was Homer Simpson. And Homer Simpson is more or less very famous, easily to recognize. But at the beginning, it was absolutely not so easy to understand it was that. We tried the de novo assembly, and the de novo assembly is trying to just attach pieces that seems that should overlap or stay together without knowing what is inside. Do you understand? We tried something without knowing exactly what is inside. In practice, you imposed some some knowledge already in your mind, because you understand at a given point in time there should be something. It's not exactly the novo assembly, but you are okay. Because sometimes, whenever we do some exercise like this in practice, we have something, sorry for who is working here, we can have something like this. We can create an Homer Simpson with a unicorn, okay? Because it's trying to touch, and he is not able to recognize the differences between, it's attaching a piece of genomes that are not exactly from the same species, and can arrive to have some kind of very bad situation. So contamination is important not to have in your samples, okay. Well, we did the de novo assembly. We didn't know what is inside, and we tried to understand, to reconstruct the DNA, even in presence of a contamination. Good job. Third exercise. Then the mapping. Now, in the mapping, we know that the reference is a face of a person. We know that. I tell you. I bring to you a reference. Look, all these short reads are part of a face of a person. With the black one are hairs or mustaches or something else, okay? So you know that. Take in consideration that they are not a unique part of a unique piece of reads. Again, I repeat, the reads can be repeated. In reality, millions of times. So here we can have more than one repetition of pieces, okay? The reference, again, it is a face. No rotation, no need to rotate, it is a face. No famous face, it is a face. Okay. Nice.
Yes.
Absolutely nice. Okay. Okay, now I think that I have to open I can open.
No.
Have you okay? Are you okay? Did you like it? Okay? This is your parallel programming in making the assembly. Knowing the information, this is a phase, okay? I can show you what was the real pathogen that we are analyzing here, okay? Should be this one. The solution. This was the phase. But, well, more or less, we can say that you. What is your? Okay. Oh, you already changed it. You already changed your mapping, but it was like that all the pieces goes in the air, but it's not exactly in the air. It's more like this. So you can understand that even if you know some knowledge in advance, your mapping can be good or not good, depending on many things, okay? Depending on many things, but you can have some pieces in one part and not in another part. Okay. Hope that you enjoy this. I have something else, I don't remember. Yeah. Just this one. Yeah, I make this one by myself. This is a very pure draw of a snake. Just to let you know, we are trying to suppose this is the initial DNA, and the reads brings us to this kind of situation. A lot of short reads having the upside and a lot of downside. These are the length of the reads. Are we able to understand how many up and down the snake we have with this kind of reads? Yeah, it's not the same value. Sorry, this is just to see. Sorry, I didn't. You're trying to. No. I don't want to let you try this because it's impossible. If you have short reads, shorter than the repetition, if your reads are shorter than the repetition, you are not able to understand if this pathogen as 3, 4, 5 up and down, okay? This is a situation very common if there are pathogens with the different pieces of DNA that are just repeated, and it's not possible to understand how to reconstruct it. Hope that this liked you. Let me just, I have to go back to the, okay. Okay, yes, okay. Just I go back to the presentation and just to tell you that all these sequences and reconstruction and activities are part of the GenPad platform that in Italy is the National Bioinformatics Platform officially recognized to collect, share and analyze genomic sequences of pathogen microorganisms. And of course, it's important to know also the metadata of this pathogen. Metadata are the classical epidata that I'll show you in a minute. In practice, we can just think to this platform a place where I put all the sequences, all the reads that I told you before, and the associated metadata, and we just have a calculation engine where we do, for sure, the assembly, to reconstruct the initial DNA we are under analysis, but of course all the typing needed to characterize that pathogens, to understand if it is virulent, not virulent, if it is pathogenic, if it is resistant to antimicrobials. This is typing on the pathogen. And then bring back to the users combining the genetic distances among the samples and the position and time where these samples are found. It's important to understand what's happening. Okay, these are the WGS data. WGS is whole genome sequencing of bacteria. These are the raw data, so-called the reads that we were talking before. And then we arrived to have a contamination check, as you saw before, de novo assembly or mapping. As you can see, bacteria and viruses have their own specific methods to analyze them. The metadata are exactly the context where this pathogen has been taken, okay? And when, where, what, from what part, from what matrix. For instance, in this case, we have pathogens, bacteria, taken from an animal on a given point in a given position. Here we have a situation where we have a virus in the blood of an animal taken from a farm, or a bacteria on a human in an hospital. All these things are different situations, and whenever we see the pathogens, we would like to understand probably different things. These are the components. All of them are open source components of this platform. We can have some information on this. And these are part of the pipelines. Sorry, what is a pipeline? The pipelines is a concatenation of tools, as normally we know. It is a common term used in bioinformatics to say, look, we have to first check for contamination, then please assembly, then typing, and so on. This is a pipeline. Different from viruses, bacteria, and now we have a lot of other pipelines, some of them specific for SARS-CoV-2, that all know we experienced. We have some information on the metadata. I can skip it, because I can leave this. And then we have a dashboard components. The dashboard components tries, again, as I told you, to combine the distances between samples amongst all the samples. For us, the samples are the pathogens, then the DNA reads from those pathogens with the places where it has been taken and when it has been taken for different purposes. These are methodologies of how to calculate the distances between two DNAs of a given species. There are methods faster, but not so discriminatory, more discriminatory and a bit slow use cases. These are the cases where this platform can be applied. Let's just check. The SARS-CoV-2, I think that I don't have to explain it, okay? What do we want to know reading from the DNA from SARS-CoV-2? Please think a bit like if you are the surveillance people and trying to fight towards this pathogen. What you can do, what you want to know from the DNA. At least what you have heard on the television from the news. Please. Sorry, there is one question. Okay, okay. And what we can do with this our is one of the questions that arose a lot of time. Can we do something with this for stopping it? It's no, but it is one of the things that you want to know. And I use the DNA differences plus the metadata to understand probably in Abruzzo arrived from here, or in Italy came from in Austria, etc. Please, you have an answer? Do you have a spread capability? This is much more important, because if you know that in a given region there is a part of the DNA that explain, or at least, please, first you know the effect. You see that in a part of the countries of the world you have a place where there is a big diffusion. This is something that tells us that there are something in the new version of the DNA of that viruses that is able to better attach to human. Okay? Taking consideration the virus mutate very frequently. You saw with the SARS-CoV-2 changed a lot in order to adapt to the situation. Okay, now I change the scope. This is the same approach of looking at genomic differences can be applied to other animals, to other viruses, for instance, the West Nile virus, okay? In West Nile virus, I have to give you some, it's not like SARS-CoV-2. I cannot, if I'm sick, I cannot let you sick just with the closing us. But we need a vector. There is a vector-borne disease. That we need mosquitoes, some kind of mosquitoes. If there are no mosquitoes, one sick person cannot affect also the others, okay? Again, what can we do in this case with the differences? We normally, the surveillance is like looking at, there are capture for mosquitoes and look if there are West Nile inside. Taking consideration, West Nile can create encephalitis. It's not exactly simple disease. Okay, I'm just answering because of also the time. We need to know where are appearing. In this case, the geography is important. Appear here. And look, it's not only appearing in these mosquitoes captured, but it's also appearing at the hospitals, in persons. So we know that West Nile is dangerous and is present here. What can we do? Please go and try to put something for reduce the number of mosquitoes. There, not everywhere, you know, because sometimes it needs for this. I know that you should know that also for mosquitoes comes from birds that passes from Africa to Europe and so on. These are parts of from South America to North America. It's exactly some pathway of the birds are explaining the West Nile diffusion, just for other things. Now we change completely the context, and we are talking about Listeria. It's a pathogen, a bacteria that is present on food. In this, it's not vector-borne disease, but it's food-borne disease. You can be sick if you eat something. Normally, you go to the hospitals and you have a person sick for Listeria. You ask, what have you eaten yesterday? What have you eaten last week? And so on. Okay? What can we do normally? We do normally have some kind of surveillance on the supermarket, on the production facilities, also on farms. What can we do with these distances? I take the pathogen from the hospital sick person, and I take from the farms, I take from the production facilities. What can we do? This is the case when I can do much more than before. Remember, before I cannot, in principle, stop birds to come from Africa to Europe, or I cannot block mosquitoes to grow. It's impossible. So I can do few things. Here I can do much more. What I can do? What is my procedure that I can do? I have listeria in patients. I took listeria in several production farms. Have someone some idea? Supposed to have a CSI specialist and try to block the bad guy. What should you do? I'm trying to, I'm just comparing the DNA, finding differences, and so on. What should you do? You can block it. How? No. No. It's much more, not so sophisticated. I mean, you can compare it, and what? You will find something, no? You will find what? Some listerias, DNA from the patients, that are very far from milk production, from the listeria taken from milk production farms. What can you say to the milk production farm? Okay, you are okay. Then I go to the prosciutto farm production farms, and it looks, it's closer than this. Then I go in a tuna production farm. It's really, really close. What should I do? Close down. Close down, and I stop. If I'm very, very good on doing this thing, I have to find the pathway of the food leading to the spread of this contaminated food, and you stop the outbreak. This is the case where it's very, very effective, at contrary to the other kind. You are able to stop it. Okay? In Klebsiella pneumoniae is more sophisticated things. I think that also for the time I can stop here. Let me just check and leave the floor to, oh yes, maybe this one. I can show this one, Andrea. Okay? Andrea? Okay.
Okay, bye-bye.
I can just show you what exactly happened in the dashboard that we realized in this platform. What is the case here? The case is are all the SARS-CoV-2 taken in Abruzzo during pandemia. Okay? And as you can see, let me just check if it works. I cannot go. Oh, I'm trying to skip a bit. Okay. Okay. Okay, we ordered by dates of sampling. The yellow ones are the ones taken in the beginning of pandemia. The more are going towards the blue is more recent, okay? So here you can see that, okay, yeah. Whenever the time is now, is a time lapse, whenever it started the pandemia, you can see that there were some, in Abruzzo we are talking, but it's absolutely comparable with many other places in Italy, Europe, and so on. At the beginning, there was some spatial samples of SARS-CoV-2 very close, and if you compare them, we are leading to a branch of all very similar pathogens that are, you can see this branch, and this branch that are different. It was the beginning of pandemia. Then continue. You can see there are much more branch on the top left, and starts a second kind of SARS-CoV-2. This one were not present at the beginning. If you compare the DNA, this one is much more different than this one that was at the beginning, okay? I didn't tell you, but each circle is a pathogen. If the circle is greater, it means that much more pathogens are inside, exactly equal, okay? Like this circle means that there are a lot of pathogens with the same DNA. Okay, these are different from this one, it's a new one. If we continue, you can see in the green there, look, whenever the green increases, in the yellow part here, no one arrives. It will be much more visible with the blue one. Yes, this one. Whenever you see this, a part of sporadic cases, no other great number of pathogens arrived there. Which are this one? This is the B1, the initial one. The second one was the so-called alpha variant, or English variant. I don't know if you remember this name. Then this is the delta variant. The delta variant that arose at a given point in time. And then we have the Omicron that differentiated in several Omicron branches. If you remember, the Omicron was very differentiated with different type of. So whenever they told you alpha variant, delta variant, Omicron variant, you can understand that it's not exactly the same. In practice, yes, they are far one with respect, but not exactly the same. There is a huge differences among them to be analyzed. And etc. You can see you looking at your in the presentation to the link. I think that I can stop here and leave the floor to Andrea. Please.
Okay, morning. My name is Andrea, and I studied in l'Aquila. I graduated in software engineering, and also Adriano studied in l'Aquila. So, and basically, I am a software engineering, but in the last 2 years, I moved in the bioinformatics unit, and now I spend time in to develop some bioinformatics algorithms. You can save my slides using the URL on top. I don't know the expiration date of that link, but the slides are not so interesting, but maybe the most important slide is the contact slide. So at the end of the slide, we propose also some ideas to collaborate with us for thesis, or if, I don't know, if you have new ideas, suggestions to help us, because I discovered this morning that the audience is very good. You are more expert than us in machine learning, and there are also people that are skilled in bioinformatics. I want to discuss with you spread, and we develop several tools to apply surveillance activity to facilitate these tasks. And I don't know, okay. And but we have one big problem, because as told by Adriano, genomic data is composed by strings, okay? These data are human readable, because we can use also an editor, a text editor, we can read effectively the strings, but they are not human comprehensible. So, okay, we see strings, but what are the meaning of these strings? And we obtain the value, the information, only if we can apply bioinformatics pipelines on those data, but we should have also decorators of this data, descriptive data, and they are called metadata. So, for example, the most important information, when the sample was collected and where the sample was collected. So, how we work? There is a wet lab. It's composed generally by biologists, and they work with tangible things, samples, okay? They put these samples in machines called sequencers, and from tangible things we produce not tangible, untangible things, reads. Then these reads come in the dry lab where me and Adriano work. And we apply algorithms on these reads, and we try to obtain information from these reads. So one way to obtain information is the application of distance algorithms. So, for example, the simplest and the most used distance algorithm is the Hamming distance. Do you know the Hamming distance? Okay. And okay, if we apply the pairwise distance on these samples, we obtain a square matrix. So if we have 10 samples, we obtain 10 per 10 samples, the dimension of the matrix. And the diagonal of this matrix is always 0 because the distance of the same sample is intuitively 0. But this square matrix is not so enough, because if we want to represent this square matrix, we will obtain a graph, a fully connected graph. But we want a smarter way to obtain information from this square matrix, so we will apply minimum spanning tree algorithm. So, in this way, the graph becomes a tree. There are no cycles, and if you can see this picture, it's quite intuitive to identify clusters, because you have, for example, the first cluster, the red cluster, then you have the green cluster, and the third cluster is the azure cluster. So, from not comprehensible data, we arrive to a more readable way for humans. Okay, this is Spread. It's a web application, a standalone web application, so you can run it simply in a browser. It doesn't need a server component, so any device with a browser can run Spread. You can download it from GitHub. It's free, you can fork it, you can add pull requests, you can notify us issues. So you can do everything. Adriano showed you a video using this application, and basically the power of this tool is that we can visualize the evolution of the spread of the pathogens in 2 dimensions, time and space. So, if one idea, if you want to do to collaborate with us or to work with us, is to extend this tool, for example, or to improve user interfaces. And okay, I skip this slide because it's not important. I prepared 4 different use cases. The first one was shown by Adriano, so I skip the SARS-CoV-2. Okay, West Nile virus. you know that there are many ways to get infected, eating a food, to be in contact with infected human, to drink infected water. So you can be infected by environment, by animals, and by humans. So nowadays we are speaking about the concept of One Health. One Health is the folder that includes human health, environment health, and animal health. Okay, and our institute apply this approach of One Health. So in this case, West Nile virus was isolated the first time in Africa. So the birds are the reservoir of this virus. So the virus replicates in the bird, but mosquitoes bite the bird, and then the virus enter in mosquitoes. But unfortunately, mosquitoes will bite the humans. Okay, and so we will be infected with the West Nile virus. So it's important, for example, in this case, the nodes of this tree was colored by years. So we can study the evolution of this tree across over the years. And for example, with West Nile virus, it's important to control the roots of the birds and globally, but you can also control the mosquitoes locally. Okay. So, for example, here we can study the blue cluster, and for example, it's in the west of Africa, but this type of pathogen is arrived also in Europe, as we can see on the map. Okay, now with this picture it's quite impossible to monitor the evolution over the years. I put only the map. Okay, African swine fever, yes? Please. Yeah.
It's a separate version of the same pathogen, right?
Yes.
Okay.
And,
yes.
And the arrow is the number of differences in the DNA.
Yeah.
As you can see, blue and orange, you see 3C1, means there are 361 differences between the two DNA.
Is it in genes or is it in singular? Okay.
It's a good question, because we are showing you different trees that seems the same, but in practice for each pathogens you have different methods. In this case, for West Nile, we are looking at the nucleotide differences, not genes, just nucleotide. 361 are just a bases that are different between the two DNA, while for others, we are looking for genes.
Thank you.
Okay. Another virus is the African swine fever. This virus is not dangerous for humans, but is dangerous for pigs. And it causes a very big problem economically speaking, because when a pig is discovered infected by this virus, it's needed to kill all the pigs that are in the farm. So it causes a very big problem for the farmer. And also it's a really problem because Italy is also a country that exports a lot of pork meat. Okay. Okay, in this case, I have two pictures. On the left, a software that doesn't use phylogenetic tree, and as you can see, we have the red nodes, but only one color, and it's not so intuitive to discover that all these nodes effectively is composed by 4 clusters. Instead, if we use phylogenetic trees and spread, we can discover that effectively this outbreak it's not only one outbreak, but it's the case of 4 outbreaks because they are 4 different clusters, 4 colors, and so it's really important to have these capabilities in surveillance. Okay, Listeria. It's not a virus, it's a bacteria. It's a very powerful bacteria because it survives everywhere, on the surfaces, also in the fridge, or in our fridge. And it's a real problem because maybe this bacteria is also present, for example, in the vegetables. You don't cook vegetables, so you can wash the vegetables. And it survives also in the environment. If, for example, the animals drink the contaminated water, probably it will produce some infected food. Okay, in this case, I want to show you how it's possible to split this tree in 2 parts, because we colored the nodes by the matrix food. So in the right part we have the red nodes that are composed by isolates from food. The orange nodes are isolates from human, and the blue nodes are also isolates from food. As you can see, at the right of the orange nodes, we have a smaller distance compared to the distance that we have on the left. So, in this case, experts can decide that the suspicious food is on the right. Yes, Adriano?
Just to clarify, in this case we see always the tree, but in this case we calculate the distances between samples with using genes, and there are papers that saying if there are genes closer than 7 allelic distances, that 7 genes of differences, we can say, it is related in an outbreak. Okay, so in this case we see 3. It's a clear signal that that food is involved in the...
Yes, 7 is the magic number for Listeria, yes. Okay, maybe we can comment this slide at the end. We have several ideas. I can switch to the machine learning slide. Okay, so also, in this case, you can download these slides using the link on top. Okay, this picture illustrates the food production chain. We can have problems in every phase of this chain. So, for example, as I said before, at the beginning, the water is contaminated, the soil is contaminated. Then we can have problem during the production phase, the processing phase, distribution phase, and so on. And at the end, we can have problems at the table with ready-to-eat food. So it's really important to be proactive at the beginning, but also to be reactive at the end of this chain. Because an outbreak can cause health problems and also economic problems. So we have developed this platform. Now we collect a very large amount of data, but we don't collect not only genomic data, but in our institute we collect also other types of data that can be meshed with the genomic data, so we can develop so very complex systems. But this is not a presentation, this is a request for help from you, because you are the expert of machine learning. We are approaching these techniques using the classic machine learning, not deep learning at the moment. And okay, just only you are ninja in machine learning, but I want only to discuss the problem in bioinformatics. The most important thing for machine learning is the data set, okay? Because if you have noise in the data set, you will have, probably you will have noises in the model. But for example, if you have a collection of photos, of pictures, you can easily put labels on these pictures, because a picture is comprehensible for humans. So you can trust the labels of this dataset. But if you are speaking about the bioinformatic genomic data, you have to trust of labels put by other people, and it's not possible to apply a double check with genomic data. You can apply a double check with a photo, because if you see photo of apples, you can put the label apples. If you see pineapples, in this case, you can put label pineapples. So, but if you see genomic data, maybe you cannot, you are not able to put a label on genomic data. Only after a work by biologists, and at the end we will put a label. But we have to trust our biologists. So this is the first problem in bioinformatics when we want to apply machine learning. So, okay, the food source, yes.
Do you have other slides on the machine learning?
Yes.
Okay, no, I would like just to underline this point. That is, I know that maybe looking at food in front of the lunch time is not good, but if you are still have some concentration, it's important for you to say that how difficult it is to provide machine learning on the DNA data with respect to others. We are always mostly talking about text in LLMs or image recognition. What I would like to underline to you is the image recognition. It's easy to understand if machine learning methods has some hallucination, is wrong, and we can say is good or is wrong very easily, because it's enough that one just look to the results and in less than 1 second can say yes, it's good, no, it's not good. For the LLM, it's the same. Today, Dr. Dipenta explained very well what is hallucination, and the hallucination, to understand that this hallucination is very, very easy. One just look to the sentences, and in less than 1 minute can understand. This is not true for genomics data. If your machine learning methods says that one pathogen is resistant to an antibiotic, it's absolutely not a matter of 1 minute to understand if it is true or not. You have to test it. You have to take that sample alive, because you are looking at DNA, so you killed that pathogen. So you have to have the pathogens in one side and test it, if it is true or not. If it is, so the story to understand if a method is accurate, has hallucination, this is another story with respect to the other. So this one of the big challenges to work with machine learning on this kind of data. But it's much more absolutely important to work on this because it can save lives, really. Does not just simple answer what is the better code in Python to write this, but can save lives. But it's much more complicated. It's an area where you cannot just say, look, this not seem, I asked for a face and arrives a dog. Oh, that's good. We are talking about something more complicated. And we are looking for methods to better understand and in a reasonable time, which if the method is good, not good, as hallucination or not. This is important. I'm sorry that I understand that we are very close to our presentation, but it is an important point. Very different to other situations.
Yes. Very quick because time is finished. In the slides, I put also the links of the two papers that we have published. The first one is it's related to spread. The second one is related to our first machine learning model. And okay, very simple. We started to investigate classification models, and in the first version we used the R language, but R has two limits for us, and then we have switched to Python. We are using now Scikit-learn library, and we want to build a versatile model, so a versatile script that an end user can use different models, can train these models with different types of data, and we want also to study the regression models. So no more categories but continuous numbers, and because we want to study how a disinfectant is able to kill the bacteria growth, okay, and this value is expressed by a number, a continuous number, so we have to switch in regression. And I think it's you have the slides. We have integrated these models in the platform, so the experts now can try to apply this classification directly in the platform, and the expert will see the probability of that is the output of this model. It's a very simple model because it applies a binary classification. We want to discover if the genomic data belongs to meat or not to meat. It will, okay? And okay, you have here a diagram. We wanted to study also regression, and this is our mission, our next mission. And okay, why? Because if the model will output a high value, it means that the strain is resistant to the disinfectant. So it's important to act quickly, or maybe to changes the bad practices applied, for example, in the processing phase of the food. Okay, this is all, and we want you, because we are encountering a bit of problems applying machine learning techniques. Maybe it's for us it's quite interesting also to investigate deep learning. And I have also, we can switch to, yes.
Wait for, okay.
Thank you very much, first of all. So they will stay with us for lunch, for any questions, and you know, there are a number of them that are coming the upcoming summer that have been already selected to come to L'Aquila. Some of them may be interested to do internship before they start the study program in L'Aquila. So if any of you is interested, they will be with us at lunch, so feel free to stop them and to make a talk with them. So lunch is served downstairs in the 2 rooms where we had the breakfast and the other one. Okay, so let's go and let's enjoy lunch. Thank you. So we restart, and it's my pleasure to introduce Kartik Vaidyanathan. He was a master's student in L'Aquila in a double degree with Amrita University. Then he was a PhD student at the Gran Sasso Science Institute and postdoc at the University of L'Aquila. So we've been working since a while on integrating software engineering, software architecture, and machine learning. And I think honestly the first papers relating those 2 disciplines are, you know, our papers, Kartik. Now he's a professor in IIIT Hyderabad, where he's running a lot of interesting research with his team. So it's really my pleasure. Please, Kartik.
Great. Thank you. Thank you, Henry, for the invitation. By the way, it's a session after lunch. So, I mean, even I had lunch, by the way. And I just arrived yesterday. So I hope that I'll be also awake and you guys also will be awake. So feel free to interact during the session. I don't want this to be a one-way information dissemination like a publish subscribe architecture. So let's keep interacting, right? Yeah, so thank you, Henry, for the wonderful interaction. It's great to be here because coming to L'Aquila is always nice. It's always like my second home, as I said in the morning. I spent my 7 years of education here, so it's great to be back. On that note, if you see everywhere today, right, from the morning, of course, we have been listening, but even if not morning, you just open your Flipboard or Google News, X feeds, you could only see something related to generative AI or large language models. So much to the extent that it is becoming extremely difficult to keep track of things, right? Just when everyone thought that OpenAI is going to rule everything in the world, DeepSeek suddenly comes up with a bomb and says that, hey, you know what, we are doing much better stuff at a much cheaper rate. Why don't you guys start adopting us? In fact, because of them, OpenAI reduced the prices. They also started making things for free. Recently, let's say 1 week back, Sam Altman tweets saying that, I don't know, it's still called tweets, right? I don't know what Elon Musk is doing. Anyway, Sam Altman says that, oh, guess what? We are going to open source some of our models. So OpenAI is finally planning to open source some stuff, right? And then, of course, recently they introduced something called SWE Lancer benchmark, where you could go and solve some of the real-world software engineering tasks, and you will be judged based on how much the tasks are worth, right? Because these tasks are basically from Upwork. So if you solve certain tasks, you get paid like certain dollars. It's not you will get paid, it's like a virtual understanding of how good your solution is. And similarly, of course, Llama comes up with something. Google recently said that they are introducing something called AI co-scientist, where you could ask a model and the model will be like a peer scientist who will work with you to come up with something innovative, right? So that's the world we are heading. So much to the extent, last year I was at ICSI, and then, for that I have taken a cab, and the cab had a number called LLM. I was like, where are we heading? Everywhere we see, it's only LLM, right? So that's what we are talking about. But even in the context of software engineering, how many of you used Cursor? Cursor. Oh, that's very less. You guys should start using more of, code pilots, co-pilots, and so on. Interesting thing is there is a lot of things happening in the software engineering space as well, right? In terms of GitHub Copilot, in terms of cursors, in terms of Windsurf, and whatnot. So this talk, I'm going to primarily focus on this crossroads at the intersection of generative AI and software engineering. What does it mean to software engineering from a generative AI perspective. At the same time, what does it mean to generative AI from a software engineering perspective? Because there is also a big challenge of how do you engineer such systems, right? Everyone says, okay, let's build a LLM-based application, but there are also a lot of engineering challenges in building such applications. So I'll talk about some of the challenges we faced and how we solved them. At the same time, I will also talk about how we are using generative AI for different aspects of software engineering, right? So that will be broadly the theme of the talk. Okay, so a little bit about myself. As Henry wonderfully introduced, I am from Software Engineering Research Center at IIIT Hyderabad. I am also a leadership member of Smart City Research Center, where the entire, IIIT campus in India is full of sensors. We have like 350 sensors that are deployed across the campus, and we keep collecting a lot of different types of data, and we process this data and perform interesting stuff with those data. So I'm also associated with Smart City Research Center, and my education primarily has been in this, one direction of software architecture on one side. That's how I came to L'Aquila. I did my master's in software architecture, but before that, I did a master's in machine learning. So eventually, my PhD was in the intersection of software architecture and machine learning, right? So I don't know, was it destined or whatever? At that time, machine learning was not so popular. I didn't even know why I picked machine learning. I just thought I want to do a master's, and I said, okay, let me do this in machine learning. Anyway, so my research interest is naturally in this intersection of AI for software architecture, which is about how do you leverage AI for certain aspects of software architecting practices. On the other side, it is about how do you build AI systems, particularly looking from a sustainability standpoint, from a green AI standpoint, and so on. Some fun facts: if you know cricket, I don't know how many of you know cricket. How many of you heard of this game? Okay. I think most of them are from the Asian sides or okay, great, awesome, right? The game itself is so hard to explain, so I'm not going into that, but I'm a big cricket fanatic. I like applying AI into, going with stats on crickets and so on. I'm also a very hard time movie buff, and I am from God's own country. So God's own country, as we call, is a state called Kerala in the south of India. It's also known as God's own country. Don't worry, no one gave it. We only gave the tagline so that we get more tourists to the state. Yeah, that's the story. Anyway, so that's about myself. So just to give a prelude into generative AI, today morning Max gave a very interesting idea into generative AI, but I want to take a little bit of detour, right, to just see that we are on the same page. If you see, the quest for artificial intelligence started long back in 1943, when the whole idea was about, okay, given a bunch of text, can I predict a word, right? Or given a set of words, can I predict the next word? And this next word prediction problem is not a new problem. I think one researcher in 1950s came up with this idea that if I know these are the set of words and these are the combination, the words have been used, if I can find a probability, what will be the next word, I can predict the next word with some confidence. Right? And of course, we have seen this apply to Google search, right? If you type something in Google search, for example, what is software, you have a lot of list of words that comes up. On other side, if I say software engineering is, then I get a bunch of suggestions. If I put something in Google Translate in English, and I get something in Italian. I'm sure some of you are using this if you're new to Italy, right? If you don't know the language, you might be using something like a Google Translate. So if you actually look at what has been powering all this, it's been a bunch of machine learning algorithms, and the journey that we have gone from something called MCP, which is Macula-Pitts neural network, where you have one neuron that can take an input and predict an output, right? And then we said, okay, can we extend this? Can we make this do better? So then we said, okay, I'll introduce something called backpropagation, where I'll predict something, understand whether it is good or bad with respect to the original value, then keep propagating the error back to my network so that I can keep correcting my predictions. And then we introduced recurrent neural network, convolution neural network, so on and so forth. But the important problem again has been this, right? If I say Ediss winter school is, I want my neural network to predict happening, right? And if I pass Ediss winter school is happening in, I want my neural network to predict L'Aquila, right? Now, the next step is what is more interesting. If I say Ediss winter school is happening in L'Aquila and I say it, the question is, how does a neural network even understand what does it imply? And this has been the biggest challenge, right? Because with recurrent neural network, we cracked the problem where we said that, hey, I know what are the dependencies of it to say it actually corresponds to Ediss here, right? But how do you make the neural network understand this? And the traditional neural network, like recurrent neural network or LSTMs, which is a class of neural network, they had this problem of something called vanishing gradient problem, right? I'm not going into the mathematics of it, where they found it hard to recollect the past, right? If I know the entire context, then I'll be able to predict what does it respond to. That is when this wonderful work by Vaswani et al. In 2017 from Google came up, which is attention is all you need. Of course, attention is not the mechanism that was introduced in 2017. The work of attention actually came in 2015, but attention was used in a neural network in transformers in 2017, and then it became a huge hit, right? Now, what does attention do for people who are, new to this field is attention came up with this idea that instead of considering words in a complete discrete way, can I consider them as pairs where I initially say every word has some kind of relevance with every other word, and then I figure out how these words are closely related, right? So essentially my idea is I put Ediss as a pair, I put winter as a pair, and I kind of do a combination between all other words, right? All the pairs, IJ here, and then I figure out how much level of attention one word has to give to each other words in a given sentence. So now what happens is, if I have given a bunch of text to this neural network, the neural network probably will start understanding it actually corresponds to Ediss here, because it is trying to give attention to every other word, and it is trying to understand which word it has to give more attention to. Right? So this is the whole idea of transformer architecture. It consists of an encoder and decoder. I'm not going into the details of it, but this much is enough for our talk, the talk that I'm giving today. So essentially now what do? You say, okay, now if I have a transformer neural network that can understand the relationship between words, why don't I throw in the entire text that I have from the internet that corresponds to something like 10 billion text from the internet? Let me throw it to a transformer. Now I need compute, so let me probably have thousands of GPUs and keep training this transformer to understand the relation between all different types of words in the entire internet, so that it can predict next word. So all this effort that you're putting is to just predict next word given a bunch of words. And you continuously keep predicting the next word, you feel that you're actually generating a sentence or a paragraph, but essentially what you're doing is nothing but a next word prediction. That's why these models are also called auto-regressive models. They keep regressing back to the input. They take the word, they predict, then again they take the entire set of words, they predict the next word, and it keeps going on, and you will feel that an entire paragraph or sentence is being generated. Now, by the way, this is not something I randomly figured out, this is Llama 2's training, okay? So Llama 2 was trained on this setup, 10 billion text from internet, thousands of days of GPU time, and finally I get a model which is hundreds of GBs in size with some billions of parameters, right? Great, so that's why it's called large language model. The largeness basically comes from the amount of data they are trained on, the number of parameters that they have, the number of layers of neural network they have, right? And the kind of relationship they can split out. These models, what are these models called? Any idea? What is a class of these models called? There is a name for this model, right? Whenever you throw in a bunch of text, get a model out. Of course, large language model, but more technically, huh? Pre-trained models, right? Or a foundation model. So this is actually a foundation model. The most important thing is many people don't realize the difference between what is a pre-training versus what is a fine-tuning, versus instruction fine-tuning, versus what is chain of thought, versus what is few shot, versus what is reasoning. They're all different things. And what I feel sometimes is we just mix up terminologies like anywhere and everywhere, right? So what do you do now? I have a pre-trained model. Now what a pre-trained model has, it has the entire representation of the world, right? It has tried to capture the relationship between different words, but it cannot do anything specific to any task. It's like a parrot. You throw in a bunch of text, it will say, okay, this is the next text, because it is having all the knowledge in the world. But now I can say, hey, you know what? I have a pre-trained model. Now I want it to be customized for something very specific, like software architecture, right? I want my model to give me answers. If I ask a question related to software architecture, I want my model to say answer with respect to software architecture rather than, kind of coming with something random. So what I do, I'll say, let me fine-tune my model, right? Because I have a pre-trained model which has all the knowledge in the world. Now let me fine-tune for a very specific task. Now how do I fine-tune? You just probably, create a bunch of question-answer pairs in software architecture, and you label the data, you create this data, and you put it to this pre-trained model, you fine-tune the model, and you get now a fine-tuned model which is very specific to software architecture. Now you ask a question in software architecture, it might probably answer depending on how big your knowledge base was. So this is the whole idea of fine-tuning, and of course we have different types of fine-tuned models. Even for code, you have something like Codex GPT, you have something like CodeBird, and so on and so forth. Now, if you look at it today, we have a lot of varieties of large language models, right? For example, you have proprietary ones like Anthropic ones from Cloud 3.5, Sonnet, Haiku, and so on and so forth. You have GPT, GPT-4, GPT 3.5, GPT-O, and so on, and then you have Gemini models. At the same time, you have also a bunch of open source models. Llama came up with the initial set of models, then Mistral from Europe, from France, they came up with a model which is an open source. Mistral 7 billion parameter was the initial model. Then you have DeepSeek, then you have a bunch of models in Hugging Face, and so on. So now the question is, how do I know which LLM should I use for a given task? We don't have an answer for this, by the way. Yeah, of course you have to try, but the easy thing that you can do is you can go to and use leaderboards like LMSys, right? LMSys is maintained by Berkeley. You can actually go there and you can pick large language model you have. It's a community rated leaderboard. So you can go, you can type some prompts, and it will display a bunch of answers. You can pick one answer, and whichever answer you pick, the corresponding model that gives the answer will get the rating. And you will generate the leaderboard in this way. This is a community effort, and you can go and check models which are top ranked models and so on. Okay, so the big question that you might be wondering is, what these things have to do with software engineering? Because I've been saying a lot of background knowledge so far. Now, essentially what I want to say is that text is an abstraction of reality. It's a very important thing to understand. You cannot represent reality in the most concrete manner with text. And this is the limitation, at the same time an advantage that text provides. And this is the reason why even today we say that artificial general intelligence is a little far away, because as long as the computer vision community, they don't crack how they can solve the problem, we cannot say that AGI is here, right? Anyway, I'm not going to talk about what Sam Altman says. Okay, so why do I say text is an abstraction of reality? Now, if I'm taking this image, this is a wonderful historical center of L'Aquila, right? If you go to Piazza Duomo, you'll see this nice image. Now, if I throw this image and see, okay, describe this image in one line, you can see the description generated by two large language models below. One says that this image shows a lively public square with a central fountain, whatever, blah, blah, blah. The other says that it's a sunny day in a wide paved European square. None of this text can be used by itself to understand what exactly that image is. It's a very high level abstraction of what the image has, right? Now, why I am saying this is to make you understand that text ultimately is going to have a loss of information. Most of the information will be lost when you say something in text. If I say, I am giving a lecture to a set of students in front of me, now this can be interpreted in different ways. But if I am giving an image, it's more rich in information. And to capture image such rich in information and to generate something out of it, it's not easy. That's why that problem is very hard to solve, right? Anyway, why do I say this? Because even in the world of software engineering, you have a bunch of tasks. And most of the time, software engineering also deals a lot with abstraction. Right? A lot of things in software engineering, in particular software architecture, is about abstraction. How do you abstract things, and how do you provide abstraction in multiple different ways so that in some sense it captures some aspect of the reality? Just like this image. So if you start with design, software architecture, at some point you can look at it as an abstraction of your system. Now what is this abstracting? This is a classic C4 model of an internet banking system, right? And you can see a bunch of components, and they are connected to each other using some kind of relationships. And then you have some questions on why did they choose this particular technology, why the components are connected to each other like this, why the relationships are represented like this, and so on and so forth. Now that's exactly the definition of software architecture. The definition of software architecture also says software architecture is about components, it's about connectors, it's about the relationships between them, and the decisions on why you chose to do a certain thing in a particular way. Now, so most of the time, if you see software architecture as an abstraction, then the question you can come back and ask is, why don't we then use large language models to perform or to improve software architecting practices? Because on one side you have LLMs, which is an abstraction of text, of reality. On the other side you have software architecture, which is an abstraction of your system. Now, can they not go hand in hand, right? But then the question is, where do we actually fit this? So for a long time, software architecture community was looking at software architecture as just a component and connectors and the relationships between them, until 2005, where an interesting paper, just like attention is all you need, came up with a very interesting thought that design decisions is all you need. Now what the authors meant to say is that if you want to capture the architecture of a system, having diagrams is great, having all these different UML diagrams, everything is fine, but the most important thing is you need to capture the design decisions, which just says, why did you do certain things in a particular way, and what was the rationale behind it? If I capture all the set of key design decisions in my system, I am essentially trying to capture the architecture of my system. So then the question was, given a software system, can I understand why a person or why an architect went with a particular decision? And this is a big issue. Because in any large organization, one of the key issues that they face is there will be an architect who would have built a nice system and who would have taken a lot of decisions along the way. For example, I would have selected Java over Python. I would have selected monolithic architectural style instead of microservices. I would have selected Kafka instead of RabbitMQ. Now, most of the decisions I would have selected because of my own intuitive reasoning, right? And it's there in my head. I wouldn't have captured it anywhere in a document or something, because I'll say, oh, you know what, documentation is so boring, I don't have time to do this. Now, imagine you as a new developer or you as a new architect, you join an organization and you want to understand how the system works. Even in your code base, right? Just take your code and give it to your friend and ask them to understand how this code works. They'll be like, bro, can you sit with me and explain how this works, right? Because it's difficult to figure out. And now, interestingly, this person at some point is going to leave this organization, and after some point, you'll be like, I don't understand anything why the system has been built in this particular way. I don't know, because the guy who actually built it has left the organization, and when he or she left the organization, they also took away the knowledge on why did they do in a particular way along with them. And this problem is called knowledge vaporization. So this problem is a real problem. If you talk to industries, they'll say, yes, most of the things that we have is not properly documented. Most of the decisions we took is not even captured. And we are always trying hard to identify why did we do, what did we do. This problem has been trying to be, the community from software architecture has been trying to tackling this through this area of architectural knowledge management, where the idea is, how do I capture, codify architecture knowledge in the most appropriate way so that any stakeholder, it could be a business stakeholder, it could be a developer, it could be a software architect, they could find the reasoning, they could identify the entire, they have the complete trace of your entire system's architecture. And interestingly, in 2016, a paper came up. It says 10 years of architectural knowledge management. And what it says is that most of the time you come up with different tools, different kind of approaches, and say to the architects, why don't you use this? Why don't you try this? They'll come back and say, oh, you know what? It takes a lot of time to do all this. Instead, if I just say, let's build this and start building together, it's much faster than me having to take time to write this big documentation. So this Professor Paris, who is one of the well-known figures in software architecture community, 2 years back, in one of his keynote, said something very interesting. He said that we need to come up with better tools or better approaches which can take away this task from software architect and can automatically infer these decisions, infer this architectural knowledge from source code, rather than the architect having to sit to do all this manually. So can you take away this? right? And the interesting proposition he had is, why don't we come up with something called arc boards or co-pilots that can kind of help the architect with all this knowledge management. So this is exactly we started with. So we said, why don't we then start tackling this problem? Of course, at that time I had a PhD student who wanted to look into applying generative AI, and this seemed to be a very interesting problem, and he came from industry, so he had faced the pain. So he was like, why don't we do something to solve this? So we said, okay, how do we approach this? We said, okay, if you have an organization, you're for sure bound to have some kind of repository where you have all your source code. And now, why don't I leverage that information? Why don't I take the information from your source code? Why don't I take the information that is available in common world, right? For example, if I take all the open source repositories, can I identify standard architecting practices from open source repository, take that, mine this information, and store it somewhere? Now, given a specific organization, given a specific repository, I identify what are the best practices for that organization, I augment these information together, and I start, reverse engineering my system, reverse capturing the entire architecture knowledge from code base, and kind of provide an aid to an architect. So this is the concept we came up with. We said, okay, generative AI could be leveraged for architecture knowledge management, but this is still very high level. This is still 14,000 feet or 20,000 feet. We wanted to go further, deeper down, and start solving one important problem here. And one of the most important problem is, how do you capture design decisions? Now, one of the easiest way that has been recommended is to use something called ADR, which is architecture decision record. Now, ADRs are supposed to be lightweight documents where you store the design decisions in a markdown file. And these ADRs are typically stored within the code repositories where you have the source code. Now, one of the example ADR is what you see here. So for example, we are making a decisions between, I want to decide the technology for data analysis component, and I need to decide whether I need to use Python or I need to use R. I mean, someone in the morning was mentioning they choose R for performing data analysis. And then what do? You just put the decision, you just say that, okay, we have decided to use Python as our language, and you give some rationale on why you're going with Python. And then you have a status which says whether you have decided this decision, or this decision is in progress, or this decision is in proposal stage, or what stage of the status it's there. And then finally the consequences of choosing this decision. Now this is typically how you can capture your architectural decisions in a very lightweight manner. And this is not something that exists only in research. It's something that came from research, and it has been exploited a lot in practice. If you go to AWS blogs, if you go to Microsoft blogs, if you go to IBM, you see a lot of interesting use cases of how they leverage ADRs. So the question then we had is, can LLMs be used to generate architectural decision records? And second question is, can we use LLMs to extract ADRs from source code? Because if you do this, there is at least a doorway to say that, okay, we can do architectural knowledge management starting from architectural decision records. So we performed an exploratory study. So we said, why don't we do this? We take a bunch of LLMs, we take a bunch of ADRs that are available in open source repository, we try with different, of course, prompting methods as well as fine-tuning, and see if LLMs can generate architectural decision records, right? So we took 3 different types. What we did is we did a zero-shot approach, then we did few-shot, and we also kind of did a fine-tuning. And then our idea was to apply a bunch of LLMs on different ADRs that are available in open source repositories, come up with results to the community to see how mature are they and what research we need to do further in this direction. Of course, this was published in a conference last year in ICSA. So just to give an idea, for zero-shot, what did we do? We just gave a system prompt. The system prompt was, okay, this is an architectural decision record for software. Given a hash context, you need to generate a decision. That was the system prompt. And the zero-shot goes something like this. You give a context, and you ask the LLM to generate the decision. Okay, this is sometimes going crazy. Yeah, okay. Now, in the few-shot, what we do, we give some examples of some pairs. So we give a context, we give a decision, we give a context, we give a decision, and now given a new context, we see if it can generate a decision or not. And we also fine-tuned. So we took 2 different types of model. We took encoder-decoder model as well as decoder-only model. So decoder-only model is GPT-2, encoder-decoder model is T5, right? So T5 based models requires you to give as question answer pair. So you have to give it as a pair, whereas a decoder only model expects you to just give it as one complete string because it's going to generate the next word continuously, right? So we also fine-tuned the model. So we totally selected 18 different models. We selected both encoder, decoder as well as decoder only models. We used both text chat models as well as text completion models, and we used models with different sizes, right? So we had models with starting from 124 million parameters up to 175 billion parameters and even more with GPT-4, right? Trillion parameters, because trillion is just a guess, by the way, because they have not revealed how many parameters they really have in their model. Okay, so then we wanted to compare how good they are, right? So one of the biggest challenges in large language models for text generation is how do you compare the accuracy of these models, right? Because every time, I think Andrea was saying in the morning that in text, at least you can see the text and see how good this is. But even the problem is, how do you automatically evaluate how good a text is, right? So there are a bunch of metrics that are defined. For example, there is something called Meteor, there is something called Rouge, there is something called BERT, right? So we said instead of relying on one score, why don't we compare the ground truth with the generated text across different scores, right? And there are some interesting observations. The zero shot, of course, GPT-4 was performing the best, no questions there. Few shot, we had some strange behavior because, by the way, how many of you know why few shot works? You know few shot, okay, why does few shot work? Okay, you had to say something? Okay, anyone else want to comment on this? Okay, you can Google this, you can find this. There is no theoretical evidence on why few shot works. Okay, it's called in-context learning, ICL, where the model, we believe, is trying to learn from the context, but no one knows why it works, right? There are multiple people reasoning it from multiple angles, but no one has figured out, and this is actually an evidence for that. In few shot, we observed that some models perform worse than zero shot because we felt that it was trying to force fit, and in trying to force fit, it lost the generalizability, right? And then the final thing we did is we fine-tuned. And the most interesting result we had is smaller models like GPT-2, Flan T5, that can run on your laptop, were performing closer to larger models like GPT-4 and GPT-3.5 when we fine-tuned, right? So this, I believe, has a big relevance in software architectural space because as an organization, you don't want to give away your data to some third party or some proprietary models. So we said, why don't we then focus on this part, which is about building smaller models which can perform closer to larger models, right? So that became our pursuit because that was the result we got. And if you are very much interested in the study, you can actually go to this repository. You can find our notebooks that we have used for fine-tuning. We have used all the different scripts that we have used for performing different kind of experiments. So the natural question that you can ask, I have done zero shot, I have done few shot, and we also did fine-tuning. We didn't do one thing. What was that? So if I have a bunch of knowledge, given a context, I need to generate a decision. So what could be a technique that we could leverage? Yes, great, right? So natural question that people will ask is, why didn't you try retrieval augmented generation, right? So of course, this is some of the examples of the generated decisions. You can see the fine-tuned Flan T5 was almost generating a very good decision compared to very similar to GPT-4 in zero shot. GPT 3.5 was blabbering a lot. It was giving so much of text, unnecessary text. I don't know for what reason, yeah? So the next thing we had is, why don't we do RAG? Now RAG, for people who are not familiar, the idea is very simple. So if I have a text called software architecture is a set of components and connectors, so that's one definition of software architecture. The other definition of software architecture is about forms, elements, and rationale. This is a very interesting definition that came in one of the first papers of software architecture in 1992 by Perry and Wolf. Now what do I do for doing retrieval augmented generation is I convert both of this text into something called an embedding, right? Of course, for now, simplicity, we can just say that it is some floating point representation of your text relevance, okay? Now I create two vector embeddings that represent each of these sentences. Now I have to ask a question saying, what is software architecture? Now I want my system to combine both of them because it understands that software architecture matches with the two data points that I have. It takes them, and then on top of it, I apply an LLM, right? Then it generates the decision, or it generates a response. So what it does to do, it takes the matching documents V1 plus V2. So V1 is software architecture is a set of components and connectors. V2 is software architecture is about forms, elements, and rationale. Now if I ask what is software architecture, the generation will do something like, software architecture is about components and connectors. It's also about forms, elements, and rationale, right? So this is basically retrieval augmented generation. So we also did this, right? So we created a copilot. It's called R Copilot. We built a RAG-based tool where people can go and ask questions. They can put their architectural knowledge in terms of ADRs, and you can ask a question. It will generate a response. And the most interesting observation we had is it was working very, very poorly. Right? The reason is, if you actually ask around many organizations, if they have tried to build RAG-based tools, they will say RAG sometimes may not work. The reason is that the more the data you have, it becomes very difficult for the retrieval to identify or distinguish the difference. And that's why I gave you a very small example before, right? It becomes, retrieval is just going to retrieve based on the similarity of the text. Mostly it uses a cosine similarity. You can even use complex similarity methods. So it tries to find similar records, and it will then generate on top of it. Now the problem is there might be many similar records, especially if you look at something like architectural decisions, because there will be Python related decision, there will be Java related decision, there will be a lot of decisions. I don't want it to pick random things. I want it to pick which are very relevant for my given context, and RAG was not working very well. So we said, what did we do further, right? So that's when we came up with a very new approach, right? So this is by the way, this is a graphical abstract for a work that we just submitted, or it's kind of under submission. So we said that if you look at the journey of a software architect, right? One of the biggest question is, how do I capture my design decisions? I've taken a lot of design decisions, and I don't have a method by which I can generate these design decisions from my code base and so on. So the question then architects have is, can LLMs help me? Yes, LLMs can help you, but then the biggest challenge is your organization is going to come back and say, hey, you know what? I don't want you to use proprietary LLMs and give away the important, sensitive information of our organization to some third-party LLMs. Instead, I want you to use something in-house and something very customized. And then the biggest challenge is then, can you build something which can run on your laptop, which has all the access to all the context, and it can generate equally good design decisions, which is comparable with your large models like GPT-4. Right? So we came up with an approach called DRAFT. DRAFT stands for Domain-Specific Retrieval Augmented Few-Shot Tuning. If I have to explain that, it'll take another 1 hour or 1.5 hours, so I'm not going into details of that. Just to give a gist of it, it's a very novel approach to perform fine-tuning, right? Usually fine-tuning is done in a particular way where you give a set of, which I started with, right? You give a question, you give an answer, and you ask it to fine-tune, ask it to learn. But what we are doing here is, we do a retrieval as a pre-step to performing fine-tuning, and we use retrieve plus generated response as the way to create a data set to perform fine-tuning. So the results is something like this. We observed that with DRAFT, which is our approach in this image, you see the green points there, they were performing better than GPT-4 or GPT 3.5 or any large model in a very specific context of software architecture, and these models can actually run on your laptop. Right? And you can even fine-tune in your laptop. And we didn't just evaluate them using some nice graphs and nice metrics. We also went to 40+ architects. We asked them to use our approach. They gave some feedbacks on how good it was. We also learned a lot of interesting things. But one thing for sure is, we observed that these kind of approaches are more appreciated because it's more running locally in machines, and they don't have to rely on third-party large language models. So we said, okay, this is great. We could generate design decisions. We can have LLMs that run on your machine that are equally comparable to larger models doing retrieval augmented generation. What next? So the next question we had, it's more like a thought that came up from one of my students. During one of the discussion, he said, most of the LLMs today can generate snippets of code. Max had shown this in a morning lecture, right? But can they generate an entire architectural component? That was a question we had. So when I say architectural component, in a simple sense, of course, if you are talking about a monolithic system, I mean, what is a component, what is not a component is always difficult to distinguish because it's one large code base. If you look at microservices, in microservices what happens is every service becomes a component. right? We said, that's also a larger system. Can we go a little more fine-grained? So the fine-grained unit of computation that we have is a serverless function, right? You write a serverless function, you say deploy, you don't know where it gets deployed, some cloud provider is going to take care of that for you, and it will run somewhere, and it will execute a business logic, right? So our question that we had is, can we automatically generate a serverless function given a prompt, right? And it should be in compliance with the larger repository. So for example, if you just ask questions like, hey, generate a serverless function to perform addition of 2 numbers, it will generate. But that's not the point here. We want to generate something which is very specific to a business domain, right? You might be thinking, oh, why is this guy even doing research there, right? Okay, so what did we do here? We use this idea of mass language modeling. This is something Max introduced in the morning. So in mass language modeling, when you want to do training in an unsupervised way, you mask a word and you expect the model to generate the word and you compare how closer the word is with respect to the masked word. We said, can we do the same thing for code, right? So if you have a repository of a bunch of serverless function, I mask one serverless function, I give the complete description of all other serverless function, now I ask an LLM to see, can you generate this function which is masked, right? So this is what we try to do. And why did we try to do? Because if we can do this, it means that essentially, when your system is running, when you have a requirement, you can automatically synthesize a new function that never existed in the system when it started executing, right? So this was the whole reason why we started with this, yeah.
So that means that if this tool is perfected, then there will be no need for programmers on the software.
Oh my God, I don't want to go there. Yeah, I mean, the idea is, it won't replace, but our observations are very interesting because we feel that it could be a very great tool, an aid to an architect. So just if you are an architect, you can do many things without requiring a lot of support from developers. Let's put it that way. Yeah, great point. Okay, so what did we do is, we again did a study here. So we took 1,000 repositories that are available in open source literature in terms of serverless functions. We started pruning them. Because one of the biggest reasons why we want to prune them is related to what you asked. If you generate a function, it's not important you just generate some random function. The function has to be functionally correct, right? Which means, how do you test if a code is correct? By writing a test. So we had to find repositories that had test cases and that had coverage at least greater than 85%. That's the threshold we kept. We couldn't find many repositories with 100% test coverage. So we took repositories which have at least 85% greater than 85% test coverage. So that resulted in like 4-5 serverless repositories. We ensured that they are from different languages. So we had Python, we have TypeScript, we have Node.js, right? And in total, we had 145 serverless functions. And now the next question we had is, how do we test them, right? How do we prompt them? Again, we use 3 different types of abstraction, right? So what are those abstraction? One is a zero shot. So we give a readme of the repository and say, okay, generate this function for me. Okay, we mask one function and we give the readme and say, generate this function for me. The second type of abstraction we had is, we do a zero shot with code-based summarization. So we ask the LLM to generate a function, but we also give a summary of the entire code base without that function, right? With all the other functions. Yeah. It's a text summary. It's a text summary. So we used a different model to generate summary, like Cloud 3.5 using Cursor, and we ask the other LLMs to do this. And then we do a few shot. In few shot, what we do is, we also give some examples of functions that has been generated in that particular repository. Now, why this is important? Every organization has a style of writing code, right? And every repository somehow reflects every organization. So we said, we also give some examples and see how good they perform. And we chose these different models. We selected Gemini 1.5 Pro for doing summarization. Then we selected RTGen's Coder, then CodeQuen, which is from Alibaba. We had DeepSeek V2, GPT 3.5 Turbo, and GPT-4. By the way, DeepSeek we selected not because DeepSeek is popular now. This is based on a leaderboard we had called Evo Eval and Human Eval. That's a classic leaderboard benchmark that is available for source code. So we selected models from there. And these are the results, right? Of course, we observed that the best performing model is DeepSeek, even back then, even before DeepSeek R1 became popular. But it's not the most interesting aspect. The most interesting aspect is we perform the test by using 2 different types of intervention. One is what we call as type 1, where we don't have any manual intervention. Whatever the code that LLM generates, we just pass the test cases and see if it passes the test case. The next type is what is called the type 1, which is with intervention, where we as humans, we went through all the 145 generated functions. We saw if it was about small fixes, like adding a new brace or adding a parenthesis, how much they can improve. And we noticed that even with a small intervention, LLMs were able to generate very interesting code that was mostly functionally correct. Yeah. Yes, yes. Yes. So we ran a bunch of tests in order to evaluate their capabilities across code quality, right? What I mean by this, first was lines of code, then it was about cyclomatic complexity, the number of conditions that they have, then cognitive complexity, how much complex operators they used, how easy it was for a human to understand, and finally also the Halstead volume, which talks about the number of operators and operands in the source code, right? So we did check across LLMs with human written code versus LLM generated code, and the interesting result we have is the quality of the code was much better with LLMs. Okay, I'll take a pause. Now, that's also because of the fact that many of them were not functionally correct as well. So you cannot just correlate as it is, but we observed that in general, the quality of LLM generated code was much better than human written code, right? Yeah. Yep. Yes, so that was always the case. It was always working. So that's why we have this percentage. So this percentage is actually the percentage of how many test cases they passed, which kind of gives an idea about, you know, if they were functionally correct, to what extent they were functionally correct. Yeah. Feel free to jump in with questions, yeah? I'll be happy to take questions as we go forward. I mean, you don't have to wait for me to finish the entire thing and remember everything. Yeah. Yeah.
So, like, what were your parameters for code quality when you were checking the quality of the generated code from the LLM? Like, were you checking about the modular nature of the code as well, and was it like this the simple quality, like if the braces are not?
Okay, good question. It was just these qualities. So we were just comparing the cyclomatic complexity of the ground truth, which is the already existing code, and compare it with the what LLM generated. That kind of metrics, that's it. Yeah.
So you say that this cannot be correlated to... So basically, this includes some code entries that are wrong. That's why it's not super representative result.
Okay, what I can say is on average, even with the correct one, the similar behavior is what we saw. That's why we reported like this, right? Otherwise,
so even if you only take into account the functions that pass the test,
it was almost similar. Yes.
Okay.
Yes. Very good point. Yes. Great. And then we also tested for code blue. So code blue actually tells about the similarity between two source code, right? Blue score just tells about syntactic similarity. Code blue also talks about semantic similarity because they use abstract syntax tree to compare how good the generated code is with respect to the existing code. And here also we observed that as we improve the prompting style, as we give more and more details about the repository to the LLM, it was able to generate code which is of very high quality compared to a non-LLM code. So what we have as an inference, a quick gist of this work is human architects plus models, right? Plus a little bit of dev support, you can pretty much automate many things, right? Now, again, I don't want to say that they will take over the job or anything, but I have one more inference that I'll put up in the end of the slide. It's more that we need to have better architectural thinking, right? It's not important you become like developer thinking. We need to have systems level thinking, which is a more higher level of abstraction than having a low level abstraction. I mean, we need to start becoming more an architect in the coming world is what I believe, yeah. Okay, so having did this, so this was about, development. Then we said, why don't we take this to deployment and generation, right? So initially we stopped at this point of serverless function. The next important unit of computation is, why don't we just generate a microservice by itself, right? Because naturally you're progressing there. So we said, okay, do we have an interesting use case where we can try this? And the case we wanted is something like, if I have a system, and I want a service that does not, and the system does not have that service, since I ask for a service, can the system automatically generate the service, deploy the service in runtime, and give you back a response, right? And at that point, we also had a very interesting, result that we were doing, right? Because we had this concept in IoT system, which we also did with Henry initially, right? The idea that users if you go to a smart city, for example, you as a user might have different kind of requirements, and you might not want to use a particular application that is built. For example, let's say that you go to Paris. Paris will say that, okay, for Paris Metro, use this application. For Paris Bus, use this application. For Tourist Pass, use this application. For restaurants, use this application. So many applications, and you'll be like, why do I have to download all this application? Instead, can I go somewhere in Paris and say that, hey, you know what, I'm here for 3 hours. I want to do all this. Can you build something which is very specific to me? That's it, right? So some researchers were working on this parallel. They call this IoT Together paradigm from Sweden. Romina and team, they were working on this. So the question was, now, given a smart city, given such a scenario, if the user asks a bunch of questions for which I don't have an answer, and I know that I have the data for generating the answer, why don't I generate a service and serve the user? Right? So this is essentially what we try to build. So the question is about dynamically generating services that does not even exist in the system prior to the system's deployment. So the system is deployed, it is running, and now a user asks a query. Some of the services already exist, you can combine them, but some services don't even exist, but I have the data for those services, so I dynamically build the service and then serve it to the user. Right? So this is what we did. Yeah. Yeah, definitely there are a lot of vulnerabilities. We did it out of a craze here, yeah. So there are a lot of challenges there. So I'm not denying that it still requires a lot of proof checks and stuff. Also, we don't have a very interesting result here. So this is the idea we did. So we have a bunch of services. We have a bunch of databases. Each service is using its own database. Of course, it's a microservice architecture. And now based on the query, we have a query generator, query parser that understands the user query and then converts into some kind of a goal and then converts into a prompt which can be used to generate services at runtime, right? And this is the results we have. We also tested with 15 users asking them to use this application. So we built an application that dynamically builds application based on your requirements, right? And we tested with a bunch of users and we observed that, of course, LLMs are able to do a decent job, but generating a service alone by itself is a big task and it requires more research to be done in the specific direction, right? So there is this website for this tool. You can go there and check it. It's live. You can actually go and check how this works, what is a paper that I'm talking about and so on and so forth, right? So this paper is coming out in this international conference on software architecture, right? So with that, what did we understand? The biggest learning that we have is software architecture as a community, we don't have a lot of data set that is available in order to perform this kind of large language model related task and so on. So we created a benchmark tool, which we call as SA Bench. So you can go to sabench.com and you can see there are a bunch of tasks that are available. You can try to create your own solution for it and you can submit it and we will rank it in the leaderboard, right? So that's the whole idea, which is very specific to software architecture. It has architectural decision records, it has dynamic service generation, it has dynamic component generation, it has everything that I've been describing over the last, 40 minutes or so. And of course, we are receiving feedback, so please feel free to jump in, use it, and give us feedback so that we can keep improving. Also feel free to contribute because it's open source and there is no harm in contributing, yeah? So we want to go one more step here, right? Because we are going more crazier and crazier. So we said, why don't we go full crazy here, right? So I was talking about decision generation, decision to component generation, component to service generation. Then we were like, okay, what if a system is running? The system has some kind of flaw, it has an issue. Can we use generative AI to automatically fix the system so that you don't require much human intervention? So this concept has been there forever, right? At least from 2003, the idea of self-adaptive systems, right? So IBM, Kefart, and Chess came up with this concept called, what if systems could adapt like human cells? Right? Humans have this ability to adapt to situations, to adapt to small injuries. You are not going to apply any kind of a medicine when you have a small cut, right? It will automatically heal because humans have this self-healing ability. Our cells have this ability. So the question is, can systems also have this ability? This started a lot of research in this space of self-adaptive, software systems. And the idea is always about, if you have a running software system, to that running software system, I can attach another software system which constantly monitors the running software system, identifies if there are some problems with the running software system, and adapts the running software system. Right? So we said, with LLMs, can we do this better? Right? Or at least with LLMs, can we have a way by which it can tell the humans, hey, you know what, there is something going wrong in the system. Why don't you go and act? And these are the possible actions you can take in a given situation. So that it becomes more like an aid to an admin rather than a complete removal of the admin itself, right? We are very careful. We don't want to replace jobs, yeah? So the software system generates tons of data in the forms of logs, in the form of metrics, in the form of traces. So we said, why don't we feed this to an LLM, ask LLM to infer what is happening in the system, and kind of suggest to the humans what could be done, right? So for this, we took a very interesting case study, right? Okay, before I go to the approach, we took a very interesting case study. So we said, why don't we use this case study that is available? So there is a system called SWIM, right? It's an infrastructure, web infrastructure simulator. What it allows you to do is it allows you to simulate different loads of users, and based on that, it allows you to change strategies on whether you have to add a new database or a new server, or you have to, maybe reduce the graphical content on your system so that more users can be served. So it allows you to perform different strategies based on the workload that is available in the system. So this is a very known solution that exists, and there has been a lot of solutions that have been proposed in literature to handle this using different kind of algorithms. There are game theoretical approaches, there are dynamic programming approaches, there are greedy-based algorithms, there are genetic AI solutions. So we said, why don't we use LLMs also there? So many solutions exist, right? So we initially came up with an approach. We said that to a running software system, I can attach a monitoring component that constantly monitors all the logs of the system, all the metrics that is there in the system. Then based on this, it generates a prompt, right? Dynamically, it generates a prompt which says that, hey, you are a system, you are an admin, this is the amount of CPU consumption currently, these are the amount of users that are using the system, this is the current response time, and these are the actions you can take, right? And it goes to an LLM engine. The LLM engine performs an action, gives out a response. This is parsed by a response parser, which is further verified by a verifier, and it is applied back to the system, right? And of course, we also keep track of the history of conversation. We also have a bunch of fine-tuned models that could be used, and there are a bunch of system prompts, right? And we wanted to see how good they are. And this is the result we got. So SWIM, by definition, comes with a reactive adaptation strategy, which allows you to adapt your system based on some challenges, right? For example, if your response time goes up, you can see it went above 0.6, suddenly it added a new server, right? Similarly, let me see, yeah. So you can see that it went above 0.6, it immediately added a server, right? The number of user requests went up, the response time went up, it added a server. But if you see on the GPT-4 on the other side, it ensured that the response time doesn't even go above 0.6 because it was always able to optimize in such a way that your system always guarantees a response time which is less than 0.6, which was the threshold, right? This was a very interesting result because LLM by itself is able to understand what is happening and is generating decisions. But the caveat I want to say here is one thing if you observe is every time it is trying to optimize the response time, it is also reducing the graphical content. So for a user experience perspective, this is so bad, right? But whereas on the other side, even though response time was exceeding, it was not playing too much with the graphical content. In that sense, the user was not feeling much, sad about the experience that is being offered, yeah? So we said, we don't want to remain with ideas that are there in research. We want to take it to production, right? It's not just about coming up with interesting ideas, but you can ask me, hey, Karthik, you wrote a bunch of research papers. Where did you apply all this, right? In fact, many of the things that I'm talking today is also coming from practice. Now, what is the practice I'm talking about? I'm talking about this use case of, cloud operations. How many of you are familiar with cloud ops? Okay, some hands. So, cloud is one of the very interesting and very challenging and diverse domain, right? Today, if I say that I want to use a cloud-based solution, the first question that you will ask is, okay, which cloud provider? You want to go with Azure, you want to go with AWS, you want to go with GCP or Oracle, IBM, so on. And then each of the cloud providers also provide a bunch of services, right? For example, AWS will come back and say, I'll provide you these kind of servers, these kind of databases out of the box. You can use Bedrock for training your own large language model, so many things. Azure will come with OpenAI-based services. So many services are available. One of the biggest challenges, if you ask any company who has cloud-based solution, they will say, boss, the amount of money we are spending for cloud bill is crazy, right? The amount of people you need to manage your cloud is also crazy, because you need dedicated people who understand cloud, who understand how AWS work, who understand how Azure works, and they need to constantly keep track if there are some security issues, if there are some cost-related challenges, if there are performance issues, and they need to perform actions based on that. Right? In order to solve this, of course, AWS came up with this solution. They said that we have created something called well-architected framework. It's called WAFR, W-A-F-R, right? It's called well-architected framework. What it says is a bunch of principles. If you are a cloud consumer or a cloud customer, if you follow these bunch of principles, they are guaranteeing you that your system is, working as it is expected to be, right? This is what AWS WAFR comes up and says. Then the question is, who will perform all this, right? So we partnered with a company that's called Monty Cloud. So they are the company who are primarily performing this for AWS, right? So they are one of the premier partners of AWS. What they do is they act as the intermediate between the cloud provider and the cloud consumer, and they say that we will take care of your cloud footprint. We will tell you if the cost is going high. We will tell you if you're if there are so much of issues that are happening, we'll tell you if there are performance challenges, and so on and so forth. So they said, can we build a copilot, right? They said, can LLMs help us? Because there is so much of data, it's so complex, can LLMs automate some of this process? So this is what we built. It's called CloudOps Copilot. I can only show this much of a demo. It's a much interesting tool, but due to NDA, I cannot show much more results because, of course, it's a production tool. Yeah, it's used by a lot of customers. So what it does is basically allows you to go through your cloud footprint data. It can give you suggestions on maybe switch off the servers, change the server from this region to that region, improve your security so that it does not, or fix this kind of issue so that there is no security vulnerability and so on, right? So, and this is all taken care by an LLM, and it will only require human support when it requires an approval. For example, if it has to automatically switch off a server or switch on a server, it will ask for approvals. Can I go ahead and do it? And if you say yes, it will go ahead and do it, right? Till then, we have automated, right? Because we didn't want to give away that control to LLM because it can do crazy stuff, yeah? So this is called Monty Cloud's CloudOps Copilot. It's there in production. You can go to the website and you can see it. So we had a lot of challenges when we built the system. So this is the other side of it, right? Everyone talks about using generative AI and everyone says, oh, generative AI is fancy, you can do amazing stuff with it. But building a generative AI-based system is not easy. And especially if you want to build it for scale, it comes with a lot of challenges. We had a lot of challenges as well. One of the challenges in cloud that we faced is distributed data that comes in. Because I was talking about cost-related data, performance-related data, security-related data, all these are different domains. And all this data coming to one LLM, it was kind of hallucinating like crazy, and we were not able to handle it. Most of the time, the customer will ask something, the LLM will say something else, and they were finding it very difficult. In fact, they even said that, Karthik, what should we do with this product? I mean, it's something wrong here, yeah? And we were using RAG, by the way, yeah? And then it also started becoming a maintainability challenge because the code base was becoming larger and larger. The company came back and said that we want our developers to be able to build their own solutions for what they want. So some developer can build something specific to security. Some developer should be able to build something specific to performance, sustainability, and so on, right? And we were all relying on a single vendor. We were all relying on single LLM, and this was also becoming a challenge because every LLM, when they release, they also release prompt guidelines, they also release formatting guidelines, so we have to adhere to it, and it was becoming very difficult to manage all this. So the biggest question is, what do we do now? What do you think we should do? Stop using LLM. It had a very nice use case though. What do you think could be a potential extension here? So your traditional one LLM approach is not working because you have so much of data coming from diverse sources. The logical next step could be, yes, we went somewhere there. We said, why don't we go to the agentic AI side of it, right? And this is where we started exploring this agentic AI systems, right? So what is an agent? Of course, some of you are very familiar with this, but basically agent is any system or program that can autonomously perform a task. And this is very important. Autonomy is very important in agency, right? If you say something is an agency, they have the complete autonomy, right? So the agent is something that can autonomously perform a task on behalf of a user or on any other system, right? And basically each agent has a bunch of a role and a responsibility, and we can say that it can also leverage whatever tools it wants. Now, the difference between an API and an agent is an API, you probably, I mean, of course, agent can be invoked through API. If you recently you saw that Satya Nadella in one of his interviews said that SaaS is dead. How many of you heard that? SaaS is dead, right? SaaS is dead. He didn't say that SaaS is completely gone. What he said that instead of traditional SaaS, it will be more like agentic, right? Every company is going to come up with agents, and every agent can talk to any other agent. Now, the interesting thing about agent is you're not going to communicate using HTTP or anything, you're just going to communicate using text, right? And it's about the responsibility of the agent to figure out, if you're given a task, how to perform that task, because agents are supposed to be autonomous, right? And there are a bunch of frameworks that exist like Crew AI, LangGraph, Autogen from Microsoft. There are a bunch of agentic frameworks that exist. So we said, why don't we leverage one of those agentic framework and build the solution? Because one thing we observed very clearly here goes back to the classical software engineering principles of domain-driven design. Every domain, like security, sustainability, performance, cost in cloud requires domain expertise. And you cannot ask one LLM to do everything, right? So we said, can we do multi-agent here, where the use case is something like this? If a customer comes and says, improve the security score of a production application, you want a bunch of agents that work together and kind of solve the task for the customer, right? And on the other side, we also wanted to create something like this, which is like an agent marketplace, where any developer or anyone can come and put their agent to this agent marketplace, and you should be able to use this agent whenever you need, right? So with this idea, we created something called Moya. It's a new framework. It's called Meta Orchestration Framework of Your Agents. This work has been published in a conference in AI engineering that's coming up soon in April, right, in Canada. So this will be published in Kine. So, and we will be presenting it. So this is called Moya. The idea is to go away from traditional frameworks like Crew AI, LangGraph, which are very monolithic in nature. We wanted something that gives more flexibility, where you could add different agents, and you should have the capability where one agentic system could be built using Crew, one agentic system could be built using LangGraph, one could be built using Crew AI, and together they can interact. Right? So that's what this framework supports. So that's why it's a meta orchestration framework, right? And of course, we have a lot of features built into this framework itself, which provides support for guardrails, which allows you to orchestrate between different agents. We took inspiration from the concept of service discovery. We created something called, agent registry, where you can register agents and you can discover agents in runtime to understand what agents are available to accomplish a given task, right? So this kind of addressed our problems with respect to diverse data sources, and now anyone can extend this because they can add their own agent to this framework. One of the biggest challenges that we are facing is the cost, because more LLMs, more number of LLMs working together, there is always a danger for cost, but we are also trying to see if we can use smaller LLMs for specific tasks instead of using larger LLMs, right? So this is where I said that it's not just about looking into using LLMs for software engineering, it's also about engineering LLM-based systems, because that also poses a lot of challenges, right? So with this, we went into the next step, which is about, can we go small language model instead of large language models, right? Let's use something which is very domain specific, right? Because LLMs are great, but there are also challenges in using proprietary LLMs. So we said, can we use SLMs that are very specific to a domain and that can work for that particular domain? We are doing a bunch of work in this. Some of these works are still under review, so I cannot present it. But we are doing works like using SLMs for function calling. So for example, if you have an IoT device and you say, switch on the lights, right? It should be able to call the function called light switch or something, and it should invoke that function, and the function should be triggered, right? So for this, you can use smaller models. Our question was, large language models are very good at it. But the question we asked is, do we really need large language model? Can we use smaller language models there, because they can run on your laptops or mobile devices? So what you see here is an example of such an application. We have built an Android app. This is in partnership with Qualcomm, right? So we used Qualcomm's NPU, which is Neural Processing Unit, in Samsung Galaxy S24's SoC. So what you see here is, when a user is asking a question, the algorithm is automatically understanding whether the question can be answered by a model that is running in the edge, or it has to ask the question to a model that is running in the cloud, right? So it uses this concept of edge cloud continuum where some of the queries are answered from the edge itself, some of the queries it goes to the cloud and it asks the cloud for the answer. And this it does in order to perform a trade-off between the latency of the response, the accuracy of the response, and the battery consumption of your mobile device, right? So we have some published works, and by the way, you can go to this website, qualcomm.com/dynamic model switching. That lists actually the work that we did for Qualcomm. So you switch dynamically between different models at runtime based on the context. We did this for computer vision. Now we are doing this for large language models as well. Yeah. So this is called function calling example. So for example, if I say something like, get the details of a breed of cat, Maine Coon, right? It will actually call the function called get breed information, and it will pass the breed name as a parameter, right? And we wanted to check how good SLMs are. We took a bunch of SLMs. We took a deep sea coder, which is a very small model, which is like a few billion parameters. Then we took Phi-3 Mini, which is also 1 billion parameter. And then we took, we also took a bunch of other models, right? And we were testing, okay, how good they are in terms of, generating the output. And we observed that SLMs are not there yet in terms of function calling, but there is a lot of potential. When we did fine tuning, they were able to improve much better. We took a data set that consists of 15,000 function calling data sets from Salesforce, from I think, yeah, it was mostly Salesforce. We trained and we were able to get a very good result when we did fine tuning. So that kind of summarizes the kind of effort we have been doing in generative AI for software engineering. So different aspects, right from requirements to design to development. We have not done much work on testing. That's not my research area as such, so I've not touched much that side. But I have my colleagues in my research center who are doing work in software testing using LLMs. Then deployment and maintenance. We are also doing something related to generating Terraform configurations using large language models, and we also have some interesting results that is currently under review. So that's basically the kind of work that we are doing. So if you have been sleeping so far because it's a nice session after lunch and been wondering what this guy is talking, everything is Greek, Latin, whatever, I have some few takeaways for you so that you can just quickly remember at least this after this session, right? So I believe that LLMs can be a best friend, especially for a software architect if used wisely, because LLMs at the end, I started with this concept that text is an abstraction of reality, software architecture is an abstraction of system. So I believe that they can go well hand in hand if used wisely, right? They also present a great opportunity for effective software engineering, because instead of, I believe that LLMs can make a good coder, a good developer, a great developer. But I don't believe that LLMs can make a person who doesn't even know programming a programmer. That is a dangerous combination. That is what we are trying to say, right? Instead, if you look at already some concepts, it can allow you to make things much faster, right? Because you already know stuff. I believe that domain-specific LLMs are the way forward. We have already very good results on this, or maybe a collection of SLMs, right? Not to be confused with the idea of mixture of expert, because that is different, okay? And we also believe that there is a need for better ways to architect or engineer LLM-based systems, because people often talk about using LLM for everything, but how do you engineer LLM-based system? That itself poses a lot of challenges. As Henry mentioned, we did one of the initial works that talks about how do you approach or how do you architect ML systems and what are the challenges there. Similarly, I think we also need to revisit how do you architect LLM-based systems. Of course, finally, I believe LLMs are not here to replace, but to support. And the main thing that I want to say is systems thinking is becoming very important, right? If you don't know how to think abstract, it's becoming more and more challenging, because LLMs can only do what you ask it to do, and English is by definition an ambiguous language, right? So it's like ambiguity plus your own ambiguity in your mind. It can be a disastrous combination. So it's important that at some level you need to understand what you really want to get out of your LLMs or generative AI, right? So yeah, so the future is here. I think context is needed. How do you capture organizational context? It's a very important research problem. We are trying to do something, but it's an open research problem. LLMs will hallucinate. There is no questions about it, right? We cannot say that models cannot hallucinate, because ultimately they are probabilistic predictors, right? They will be make mistakes, but it's also about how do you engineer them. All models are wrong, some are useful, right? It's a famous line by a statistician, right? So you can only pick those useful models and make them better, right? And multiple agents collaborating, agents definitely have a big future. We are observing this with our own use case that we are building with our company, and we feel that there is a lot of challenges and a lot of potential there. And there is also going to be a lot of support for architectural migration. See, a lot of companies are still in COBOL, Fortran, right? So can you use generative AI as an aid to kind of fast track this process of architectural migration, migrating from monolith to microservices, migrating from one particular technology to another technology, because that's where you need effort from AI. Doing it human, it's a very huge task. Some companies are estimating 15 years, 10 years for performing migration. Can you do this much better? And I also believe software engineering process by itself will also need upgrades. How do you look at testing? How do you look at development? How do you look at design? Everything needs to be revisited because now you have a generative AI which is sitting next to you. So how do you say something is correct? Who is going to approve finally? So there are a lot of ethical questions also that needs to be answered. Last but not the least, I need to thank a lot of students who have been working with me because I get the nice opportunity to come here and brag about the research that we do, but all this is not possible without the effort of amazing set of students that I have. My master's students, my PhD students, a lot of undergraduate students. So many of the research that I've presented today are done by undergraduate students in my institute and my research center. So that's the group that we are we call ourselves software architecture for sustainable and self-adaptive systems. So please go and check our website. I'll be happy to answer your questions. At the same time, with Henry, we have a lot of interesting collaborations that we are going on, that has been going on with using LLMs for software architecture. We are investigating some interesting problems. So if you feel that is something that is interesting, feel free to talk to Henry, or you can write to me, and we could do something together as well. So that's it. Thank you. Thank you for having me. Yeah. A lot of questions, yeah? Okay, nice.
I want to ask a little bit of a general question again. So you mentioned a lot of different approaches in architecture, right? So microservices to maintenance to cloud deployment. So, but you mentioned that some of them were like crazy ideas that you explored, right? But which of those you think is realistic to see, to bring to the level to use for production engineering in the next, say, 5 years?
Great. So next 5 years, I think, is a long time frame because the rate at which the developments and evolution is happening, I think we are talking probably 1 year, 2 years. I feel dynamic service generation is not going to be an easy thing because companies will be very skeptical. I already am working on a project with a company. They are already like, Karthik, you don't do anything dynamic. You do something which is like, which works, gives suggestions, and we will take it to production, right? So that will take time, but the serverless component generation, design decision, I'm expecting them to see very soon in production because the maturity is there. Yeah. Thanks.
Okay, so I have a question. Correct me if I'm wrong. So you're of the view that LLM can help those people who already have some knowledge about software architecture. So what is like the guideline for those who want to expand the skill set in software architecture, but like are at the developer level? So how they can use these LLM, like what prompts they can give to GPT, for example, that to validate their software architect decision and all those sort of things?
Yeah, thanks. That was a very good question. I think we had some quick discussion about something similar during lunch with a few of your colleagues here. The problem with software architecture as a domain, right? I feel that LLMs don't have a great amount of knowledge when it comes to architectural practices or principles. It has some knowledge it has gathered from the books that are out there, whatever it's scraped. Because of this, if you even ask it to generate a plant UML diagram, right? It can generate a completely wrong diagram which looks absolutely correct to you. Right? You look at the diagram, you'll be like, oh, this is so nice. But if you actually start looking deeper into it, most of it is wrong. Right? This is because I feel it requires more fine-tuning to reach to that side. So most of the available repositories are code level. There is no architectural data that is available. That's why one of the effort that we have done is to create this essay bench, because we can put out some data sets that can be used to fine-tune or improve LLM's performance. So there is a lot of opportunity there. So to your question of can developers use, at this level, I wouldn't really ask them to just prompt LLMs and whatever it gives, use it as an architectural knowledge. But maybe when we fine-tune and improve, hopefully there is a possibility that they will become better at such kind of, possibilities. Because even there was an interesting literature study that talks about the fact that most of the works that have been done using generative AI for software engineering has been with respect to code generation and code development. Even today morning, Max, kind of was echoing the same thing, right? So there is not much work that has been done in the architectural space, and even the data is less. So that's one of the challenges there, yeah. So don't trust much, yet, yeah. Thank you. Okay, there is a mic coming your way, yeah. Yeah.
Yeah, thank you for the insightful presentation. My question relates to one of the points that you mentioned in your earlier points that you made, that text is just an abstraction of reality, in reference to the fact that, for instance, if an LLM is prompted to describe an image, it can only provide a generic description of what the image is. But we all know that performance of ML systems is tied to the quality of the data that they are trained on. So in view of this, can we sort of hypothesize that this is not a limitation of LLMs, but rather on the data, because we know that in multimodal training, the images are usually trained alongside the text. So depending on how the text that you train the LLM alongside the images, that is going to affect how it will perform on during inference.
A very good point, right? So what I meant is, okay, just a correction if that was taken that way. I didn't say LLMs are abstracting it. I meant text is generally an abstraction. Now, this is more a philosophical thought, because if I explain, forget about LLMs, right? I'm just saying, as I said, I am giving a lecture to Ediss students in a classroom. That's a description of what is happening, or I am having an interaction with a lot of students in a classroom. Let's say this is a description. Now, the image of this can be as detailed as needed or as abstract as needed. But the text is a very simple abstraction that just says something. Now, it's up to you to interpret in whatever ways you want. Whereas if you look at an image is more going to give you a very dense information, right? So that's when human eyes, if you look at it, we have the ability to perceive. So I can look at all this image and I can perceive as much as details as possible. But if I just give this image to a vision model or a language model, it can only pick few high points from this, because the feature extraction is engineered that way. And this is one of the limitations of the current computer vision models. And that's why if you see Jan LeCun, he has been saying that one of the biggest breakthrough will come when computer vision has a big breakthrough with self-supervised learning, right? Where it can infer more characteristics by looking at an image, because the amount of data, every pixel is important, and capturing all those pixels is difficult. That's why CNNs always have a way to filter out. It is not capturing every pixel, it is just doing an abstraction of some pixel, and based on that it is kind to recognize objects, right? So that's what I meant by text is an abstraction of reality. Yeah, yes, thanks. Yeah, hi.
Thank you for the insightful overview of LLMs and what they can do in software architecture. I think my question is more towards the RAG. I'm trying to understand, were you able to find the reason why the traditional RAG did not work for your project? That's one. And then I want to understand how the knowledge base was designed, because is there like a data set or a knowledge where architectural decisions are stored, and was that what was used with the information gathered from textbooks, or how did you make the knowledge base
Okay.
for the RAG system?
I'll try to answer this one by one. So the first question was with respect to RAG. So for RAG, one of the biggest challenges we had in our project, even the company project that I was talking about, for example, let me say a customer comes and asks, what are the biggest issues related to AWS S3 in security? This is a question. Now what the retrieval will do is it will try to find similar words. For example, security, AWS S3, issues. Now it can retrieve even issues which is not S3 specific from those documents. It can even retrieve documents which is specific to AWS Bedrock. It can retrieve anything, as long as there is something issue tag associated to it, right? So one of the fundamental problems that people are facing when they do RAG is they throw in a bunch of text, they convert it into an embedding, they put it in a vector database, and then they pass a text and ask it to retrieve. Now at this point, the retrieval can retrieve a bunch of documents. Some of those documents will be completely irrelevant, right? Now the biggest question that we had is how do we reduce this irrelevance? That's first. Second challenge we had is even if we reduce the irrelevance and put it into multiple RAG database, multiple vector databases, the cost of hosting a vector database is crazy high. We were paying like thousands of dollars per month. If you look at AWS provides a lot of services for storing vector data, like OpenSearch is there. The cost for OpenSearch is crazy. So the amount of data that we were getting from the system is so high that if we keep storing the embeddings of it, we were ending up with thousands of dollars per month for a very small use case. So which is why we had to find a better way, right? So one way we could have done is through some kind of a knowledge graph representation. I had some kind of discussion with this, do some kind of graph RAG. But then again, creating such large data, large graph data was becoming challenging. So that's when we said, can we separate it down into smaller pieces where we say every LLM is going to focus only on one domain. So the agentic part was working better. And some of the cases, we don't even need a retriever. We just need to pass things in the prompt itself. Right? So that is the way by which we kind of mitigated that problem. Now coming to the second problem, where did you get this data? Very good question. We took data from open source repositories. There was a nice mining study which talks about the amount of ADRs that are available in open domain. So we mined all those data. So that data became our ground truth. There are like 7,000 architectural decision records that are available in open source, as far as we know. I'm sure there might be more, right? So we took that data. Now the next work, what we are doing is we are trying to figure out, there are some repositories where ADR is there and source code is there. So there is a mapping that we have. So now we are trying to see, given a code base, can I generate ADR and can I keep augmenting more and generating more and more ADRs. So can we generate more data is something we are doing now. Yeah. I hope that answers here. Yeah, thanks.
Yeah, so I have a question regarding the architecture decision records with the LLM. So first is over-engineering, because with the amount of knowledge they have, they are very, in my opinion, they are very tend to over-engineer something. And the second thing is, if they do, and if there's, let's say, change in requirements later on in the development cycle or something, then how prone they are to introduce avalanche effects or not introduce the avalanche effects.
I'm sorry, I missed the question because of the echo. It was not very clear.
Yeah, is it better now?
No, you said it was about ADR, right?
Yes.
So
how likely they are to introduce, let's say, over-engineering of some system, the LLMs.
Over-engineering of some systems.
Yes.
How likely they are to reproduce over-engineering of some systems?
Yeah, to over-engineer something as compared, like, let's say, when you will not be using an LLM.
But, okay, as far as this research that we did, we didn't go to that side of over-engineering yet. Because that also goes into traceability of, if you keep changing your architecture at some point, can LLM say that you are over-engineering system? So we didn't take that research direction yet, right? What we are observing is here just that, okay, given an ADR context, a decision context, can LLMs generate decision for that context or not, right? Now, interesting thing that you mentioned, there is a bit of over-engineering here. When we tested this approach with architects, the one that I showed draft with architects, these ADRs are written by, whatever is available in open source is written by architects themselves, right? And there are 7,000 ADRs, as I said. Now, ADRs are supposed to be lightweight, which means that you should write as minimal as possible. Now, when we ask LLMs to generate, they are generating very closer, which means they are also generating small ADRs. Now, people are not happy with small ADRs. When we asked architects to evaluate, they are like, oh, this is very small. We want a more elaborate answer. Now, the same architects, if you ask them to document elaborate reasons, they won't be happy to do it. Because that's the whole reason why ADR came, right? They want to quickly write something so that they can store it as a markdown. But on the other side, if generative AI is doing something for them, they want it to be more elaborate. So this is a very nice disparity we observed between what architect expects versus what architect can do, right? If you ask them to do ground up. Right? So at that point, we observed that sometimes there is also a bias because some architects are more friendlier for Microsoft technologies. They are like, oh, this LLM is generating AWS related stuff, but we would prefer Azure. That is because of the inherent bias that the architect has. So this is somehow a little bit of over-engineering there because, sometimes you need too much of information to be generated, but whether that is really useful or not, we don't know. Yeah. Yeah. Any other questions? Yeah, one more.
First of all, thank you for the great talk.
Thank you.
My question is, we've seen the limitations of LLM, for example, the example you gave regarding software architecture, because we don't have a lot of resources for them to learn from. So as we move, there are going to be newer improvements, maybe tools, knowledge, and things like that. So how are you going to keep up with this? Are we going to rely on pre-training larger models as time moves on? Or we'll have to rely on things like this RAG or agents or tools as you mentioned?
Oh, very good question. So I am not going to rely on models as the first step, because I believe that models will keep improving anyway. But instead, in this particular research direction, what we are taking as a step is how do we improve the amount of good data that we have for software architecture, because that is what is lacking, right? If we improve that, I think the problem of model is automatically solved, right? Because anyway, even today you come up with a DeepSeek R1 or whatever, DeepSeek comes up with R2 or some other GPT-5 comes up, there is not enough architectural data that is available in the open source realm. So how do we first improve the data is my first question, and then I think eventually that will help in improving the tools, coming up with better approaches, and so on and so forth. So for now, the focus is on building better data sets. Yeah, thanks.
Okay, so Kartik is staying with us the whole week, so lunch, dinner, whatever, so you're more than welcome to interact with him and with us for the next days. Thank you very much, Kartik.
Thank you.
So next phase, we have 5 companies that are coming with short presentation, so they know 10 minutes. The idea is that they're all interested to interact with you, especially with those students that are already in L'Aquila or will come, this summer to L'Aquila and next academic year. And the goal of these short presentations were to introduce you to the company and vice versa, to open up a sort of link. I know that sometimes it's not, extremely easy to get in touch and rapidly get, to work with them. That's why I wanted to organize this kind of session of, brief presentation. So first company is .beyond. Please.
Hello? Hello. Hi, everyone. Thank you, Professor, for inviting me. As you see from the slide, I'm the Deputy CEO of this company. The company name is .beyond. It's a company that works in the digital innovation 360 degrees. In Italy, in France, we're opening in Dubai, so we're also opening in international markets. Just to show you what we actually do in practical, I would like to show a little video, because of course a lot of technologies that we manage, things are easy to explain, others are not easy to explain. So just see the video. Yes, I don't know if you can hear the music. Anyway, let's try. And this video shows basically this is something we do. So as you saw, these are projects, real projects we have done for our clients. Okay, so we'll go through the presentation where I mentioned this work, but it was important to show you the works we've done, because of course things are easy to explain, others not. So in synthesis, we have, these are all marketing things, there are a lot of words. I'll try to go through the numbers, which are more interesting. Disappeared, okay, it's again. And so basically we have different clients, type of clients. So we go from company clients, which are SMEs or large companies, public administration, generally speaking, and cultural institution. The company Beyond is made of nearly 200 people. We are split in 7 offices in Italy. One of our offices is here in L'Aquila, another in Avezzano, then headquarters in Roma, then we are in Milano, Torino, Bologna, Ravenna, so basically we cover lots of cities in Italy, which make easy to get people on board because we don't have any one single venue. And of course we have more or less 120 clients where we developed these 5,000 represents the number of projects we have done in our lifespan with our clients. I'll go through the portfolio where I describe the things that you saw before. We have the two main streams of production. One is based on products that we produce ourselves, and the other one is the services that we do for our clients. This is a brief summary of our products, or we call solutions. I will go very fast because this is 114 slides, so it's impossible to do all the things. So this is why I showed the video initially. So basically these are products that we produce. So the first one, Sabina, is a library management system. It's used in Italy and France by 5,000 libraries between Italy and France. It's market leader in Italy. We have 60% of market share in Italy in this area. This is another platform that is used to manage archives and museum catalogs. This is a catalog management system. This is another platform that we developed that is used to measure, monitor the risks associated to the cultural heritage sites, for instance, museums and other things that they are subject to specific monitoring requests. This is one of the products that we have in our cybersecurity area, because of course we are at Beyond have some business unit that produce these things internally. Then we own other 3 companies. One is 101 Games, that it's the company that produced the video games that you saw in the video before. Another one is SecureNext that produce Octofence and the other services in the cybersecurity. Another one is Blank Spaces, is the creative agency that produced the video that you saw before. Minux, this is a platform, it's a blockchain-based platform. This is used for dynamic NFT for certification of items, generally speaking, contracts of any kinds. This is a platform that is being developed here in L'Aquila. It is used for manage the training, mandatory and not mandatory, within a large company. These are products mainly for large companies. This is a document management service with workflow, authorization, and certification of content. This is an AI platform that integrates all the AI agents and produce a sort of balanced reasoning, because it's merged all the answers together, and is used within our clients, where we use, of course, RAGs based on the client context to make sure that the answer of the system, of course, is aligned with the client's context. And this is a live streaming environment platform. Is used to do the things that you saw in the video, where you saw people in a 3D environment. So it blends people so real people in a 3D environment. It is used for live training, for events, for presentation, for selling purposes. And it's based on Unreal Engine 5, where you can, of course, compose real-time people within a 3D synthetic environment, even realistic, of course. Then there are a bunch of services for the digital cultural heritage. As you know, in Italy, we have a lot of things in the cultural heritage area, so we manage lots of projects. 2 minutes, okay. In the digitalization, as you see from here, we do consulting for these. For instance, we help museums with developing new business models, for instance, things. We are partner in the Ministry of Cultura for creating the National Digital Library, which is the big container of the old cultural heritage that we produce with the digitalization. Then, with regards to the experience, we have virtual environments, extended reality that you saw in the video before. We also do hybrid installations, especially in the cultural heritage area. You have seen, maybe already heard the word like phygital, where they blend together an installation which is half physical and half digital for enhancing a visiting experience, for instance. And the 3D ecosystem, so other things that you saw in the video before. Here in the digital services, most of them we do here in L'Aquila and others in Torino. We do corporation websites, web portal, e-commerce website, mobile. We use artificial intelligence with our tool for enhancing capabilities of our clients. Or we produce custom platforms such as CRMs, which means customer relationship management system, or other company systems. Then I must mention we have the cybersecurity company is based in Torino. They have a SOC, so they basically have a security operations center with people that works there and manage our customer issues. And they use lots of technologies. Most of them are proprietary. We develop ourselves all these platforms like CTI, log management, and this WAAP. And gaming, that also was in the video at the beginning. We produce video games for console, like PlayStation, Nintendo, or for PC, like for Steam, etc. And also we produce metaverse experiences. For instance, in the video, you have some very quickly passing some luxury brand 3D experiences. So basically, we have built metaverse for them, and they use it for one client they use for a showroom, another client use for a 3D e-commerce environment, so they can do whatever they want with these environments. And design creativity, you saw the results. The video has been done by our department. They're very, very good at design and creativity. So we also work creating brand identities for both corporate or public administration. We do digital marketing activities, the things that you all know. And we produce UX UI design for the things for our clients. I mentioned here lots of best cases that I can go very quickly. This is a fashion luxury company that produce apparels. Time is running. So basically, very quick overview. In case you guys want to stay in touch, I go back very quickly to the first slide. My name is, as I mentioned before, Alessandro Lorica. This is my email. Eventually, if you want to have more details or get in touch with us. Maybe I mentioned we are more or less 200 people, so we're always happy to get more people on board because business, luckily, it's growing. I'm the Deputy CEO, and that's my email in case you want to contact me. Thank you very much.
Anyway, I will ask all of them to share the slides with me, and I will share with you. Okay. Okay, so next presentation is on Teams, EU data. If you could please, yes. Sandro, can you hear us?
Yes. Thanks a lot.
Perfect. You can start at any time.
Okay. Thanks a lot, and thanks for the invitation. Today I will give you a very, very brief overview of what we do in UData. Let's go. First of all, I present myself. I'm Sandro Parisi. I am the group CEO because UData is a group actually of 3 different companies, 2 in Italy and 1 based in France. We are focused on AI from a lot of years, and you can follow us and learn what we do on our channels, and if you want also through a podcast that is called Crunchycast, where we speak, unfortunately, only in Italian about AI. Very quickly, our main focus is on 3 different pillars. So we work historically in customer experience, and this is the area where we started working with AI. Actually, we use AI to provide a tailored solution mainly for large customers, mainly in Italy, but also we have customers across the board. We do more or less 20% of our revenues in Europe and in North America. Actually, we have more than 150 customers, more or less $10 million revenue, and we are proud to say that we have about 100 engineers that work in our group, focused on delivery and in producing assets designed to provide AI services to large enterprises. This is the view of the group. As mentioned, we have the main company, UData, that is focused on conversational UIs and AI-driven automation. I will go deeper in details later on. We have a company, Impact, that is part of the group located in France, and is the company that we are using to extend our business in France and in Spain. And we have a company called Metadonors that is focused on the experience of the person for the third sector. So we work here with organization instead of large enterprises. What we do, mainly three main areas related to AI. Through a common platform, the common platform is called ConvAI. We deliver, on one side, AI agent, so process automation through AI agents and orchestration of different AI engines. We deliver conversational AI in the form of chatbot and virtual assistant. And we deliver also, this is the most recent component of our proposal, document automation, which means the opportunity to work with large sets of documents that can be part of a workflow that help our customer to take some decision based on this document automation. Just to give you some examples that probably will help to understand what we do. We have a lot of customers that work in the retail area, or both for FSI and for online sales. They do with us chatbots that are used from the customer to follow the buying process, to open a claim, to resolve a problem or a ticket they have. Here we have one of the largest Italian company that does online sales of furnitures, and here we dropped by 70% the number of requests managed by their customer service. On the other side, in the FSI sector, we are now delivering a very large project for the first Italian digital bank, that is a virtual assistant that helps the financial advisor of the bank to work with their customers, mainly providing suggestions based on the company portfolio and the company processes, to speed up the answer of these employees. Here we dropped the medium time of response from 10 minutes to 2 minutes and a half. So it's very impressive. We deliver vocal claims, vocal bot that help customers to open claims with large insurance companies in Italy and in Europe. We work with some healthcare companies and hospitals to provide clinical updates that typically are delivered to the so-called caregiver, so the person that help somebody that is attending some visit or that is injured into the hospital. And in this way, we update what is happening and we update the person in order to reduce the stress and reduce the stress not only for the caregiver, but also for the employees of the hospital. Another interesting project that we are delivering now for the documentation is the so-called mortgages pre-approval. So the ability of the bank to receive a pre-approval of the documentation provided by the customers for a mortgage. Consider that they have to analyze hundreds of pages of documentation and control every consistency, for instance, on the amount of the balance of the customer, if all the data are expressed in the same way in every document and whatever. This is a process that normally takes 12 hours to be delivered, and with our platform we are able to deliver a pre-approval with a human check in less than 2 hours. So this is the impact that we have here. Another example that we have is the so-called route checker. Route checker is a platform for the healthcare that is able to guarantee that the prescription of the doctor is exactly compatible with the problem that the person has. And this is something that actually doesn't happen very often. Consider that more or less 50% of the prescription are not exactly matched with what is expected. So here we do another very important service for the healthcare system. Last, we have a system dedicated to catalog and enable users to generate automatically answers to very complex problems in a customer service. And again, here we reduced from 12 to 1 minute and a half the medium time of answer for this company. I think I'm done. So Henry, I'm a little bit in advance, and I can pass the ball to the next one.
Yes, Sandro. So thank you very much. Please send me the slides so I can make them available to the students here, and share with us your links, email address, so that if anybody is interested for this term or for the summer, when a number of them will come here in L'Aquila, they know how to contact you.
Perfect. I will do right now.
Thank you very much. Thank you. Ciao, Sandro. Graziano, please go ahead.
Hello to everyone. Nice to talk with you. I'm going to share my screen. So, I was saying, nice to talk with you. I'm Graziano Liberati. I'm the reference for the company, the Viviab. It is an Italian company that provides IT solutions. And my company, as a lot of other companies, propose in the market solutions to support digital transformation, to get it as an opportunity, and also trying to get the best as possible from the recent technology like artificial intelligence. So we try to do it in a creative way. So we try to do it combining technology, creativity, communication. So we try to implement solution with added value that get the best from all the possible channel in this digital market. What we do essentially is to become like a partner with our customers. So we try to implement a solution that establish a relationship with our customer and try to be the best solution since for the first usage of it. And we do that specifically implementing a tailored solution that, is a topic that, of course, custom development of software is also this task is done by a lot of companies. But we try to do it in a different way, providing a background a platform that proposed to our customer that is called Netido. And Netido is the platform that we built inside our company that try to make possible to get the best of the cloud native approach without giving any vendor lock-in. So we try to do this, to do that, without reinventing the wheels for each project, of course, and try to put together a lot of technology that is already in the market and providing best practice guideline for developers that needs to implement the solution. Also try to orchestrate and automate task and interaction between APIs. We try to improve the development cycle and reuse, so the usage of the code, so what we have already done. And also trying to promote the test-driven development approach. So with Netido platform, we try also to provide the cost reduction in order to have less effort, economic effort, approaching cloud native and new technology. We try to follow the best practice that are required by the current market, so to have a solution that are scalable and resilient. And also this is reached with the vendor, avoiding the vendor lock-in that I was referring to before. And in our platform, we provide also data analysis functionalities. Netido platform has this architecture, and I don't know, maybe I don't know if you can read it, but as Harry was saying before, I will share the slides after the call, so this webinar, so you will see it. And so with this Netido platform, we collected technology well known like Kafka, Rapid. Essentially, it is a Kubernetes cluster management, so the platform is able to orchestrate and manage Kubernetes cluster, and providing it in out-of-the-box way all the technology that are used in the modern software development. So we use, of course, a well-known topic like microservices, for instance, message bus, sealed secret, proxy, shield, and so on. One of the main point of Netido is the API orchestrator. So I will focus on this topic because it's the main topic that my company is interested in interacting with you, possibly. The API orchestrator in Netido is an API orchestrator that is based on the Saga pattern. And this orchestrator has the responsibility to manage all the API. So we have a catalog of API in it, so each client knows what are the API available in their solution. So in this way, the final customer apart from the technical details, knows what he has. And the catalog is very important to promote the reusage of the code. And the SAG orchestrator is also able to orchestrate the data inside the executions of each process, because the SAG orchestrator is based on process definitions, like BPM, for instance, not really that, but like it. And in each process definition, you orchestrate API and you manage data. Of course, you have the monitoring of the current execution and also the historical data of the execution that has been done in the past. And then we have also security layer that enable us to bring all these functionalities in a safe way, so without the possibility to have or try to do the best in order to have the security in place. Essentially, this is the architecture. So we have the definition, the instances, and the data of the instances that are orchestrated, and they can interact with all the APIs available in the platform. And what we would like to reach in this topic is to have artificial intelligence functionality in terms of defining processes. Because in our, this is one of the next topic that we are going to manage. Because we have the catalog of the processes that are already defined by human. We have the historical data that enable us to understand how is the performance, what is the performance of the processes, what is the performance of each APIs. And last year we did already with Muccini and Henry Muccini and his team some study on Saga API Orchestrator, but focusing on the spending time on each step of each iteration. So the usage of each API. So we would like to do something more. We would like to get those information, try to express in natural language a need to define the process, and try to propose also the API to be used that are currently in the catalog. As I was saying before, I am the reference of BBWeb, but I am also the CIO of Medias Aldona, that is an international insurance group that includes in it a lot of insurance broker covering in international insurance broker that cover a lot of countries. And with the group, our purpose is to have pilot projects to try to understand the difference of the behavior also in Italy, first of all, but covering also other countries, because the different behavior of people and the usage of the system also, in fact, makes a difference on the usage of the process themselves. So we discovered that interacting with other colleagues in other countries, and also in M&A process that we have in charge now. So this is the purpose and what we would like to do with you if you are interested in collaborating with us. Thanks a lot. Thanks, Graziano.
Please send me the slides so I can distribute.
Of course. Thanks, bye.
Bye. So next one is Armundia, will be here in presence.
Okay, perfect. Thank you, Harry. I'm very pleased to be here and to talk to you about Armundia Group. Just a brief introduction. We are a software company, based an Italian software company. Since 2007, we started as a classical small corporate, and today we are based in Italy, of course, in Rome, in Milan, in L'Aquila, and London and Luxembourg. We are a product company, so we built software and solution product for bank market, especially for finance and insurance company. So we are placed in where, of course, finance is very focused, just for sample in Luxembourg, London, and so on. And we have references in Europe and outside of Europe. We are today 300 professional peoples, and we have 75 references. 75 references that are running our solution. So, here in L'Aquila, since 2018, we decided to open a new branch in L'Aquila, a research and development center, with the goal to have a strict collaboration with the university, local university, and once again, sorry. Okay. To build a competent. Sorry. Okay, to build a competent center and a training center, and of course a research and development center for our solution. We are based in Palazzo Natellis, in the historical center of L'Aquila. So what we do? Armundia works for private banking's finance solution, and in particular in front office tools, in order to help discretionary services and advisory services in this kind of market, in insurance market for carriers and broker company, and of course in consulting to support all the processes that we follow in 30 years of career. This is our component platform that is designed here in Italy, and is an advisory platform for the services. And here are some references that are mixed in private bankings and retail bankings in Italy and in foreign countries. Okay, let's talk about actual running past project that started here in L'Aquila with the collaboration of universities and projects, and next research projects in order to support the enlargement of our solution, of our tools. These are the area, one of them, the first one that we designed in L'Aquila with a research team is an optimal asset allocation toolkit based on machine learning. I will explain in 2 words. Actually, we are working on Gen AI agent in finance advisory, and we have a lot of application in XR solution for finance market. And as you know, of course, many math and statistical financial modeling, just like risk and evaluation model, portfolio modeling, and so on. Okay, the first one, this project was very interesting because we found the way to define an optimal asset allocation toolkit using machine learning. In this case, we started from daily yields over 10 years of 19 finance assets, We explain to the guys in the problem in order to find the correct mix, the optimum mix, asset mix, with respecting of risk constraints. We used a mix of optimization tool and of course a predictive tool. Here, this was the goal to, in order to have a good advisory solution to support the advisory service, find the optimal asset mix respecting constraints. Constraints are risks profile of clients that needs to be, for compliance, needs to be respected in the services. This was a very interesting project that we built in 2019. The project is running ahead with specialization. We are working on explainability, of course, because banking services needs to be responsible and to explain the choice that are advisory to their clients. So, as you know, it's very important, this area. We are working on robust optimization, and we are working to introduce external variables, just like semantic news and so on, in order to match and to find correlation with the predictive results. Okay, another important solution that we're working on is the GenAI advisory agent. We mix a support to discover with the RAG relational database extraction under LLM, for instance, and text documents, just like documents behind functionalities, product explanation, products documents, and product sheets behind the solution. And this kind of support in GenAI, of course, is to help user to find a very natural way to understand and to find extraction information and knowledge from the data. This is based on ChatGPT or Gemini. We are mixing different foundation services. Another important aspect of our work is to respect the privacy, and so one of the goals that we are researching is to recognize and mask sensitive privacy-related data in prompting, because banks users are not comfortable to send outside to foundation services their data and of course their clients' data. So our running project is to recognize and to do a pre-processing in order to engage safety the GenAI foundation services. Another very important project is the code analysis. We are engaged in some reverse engineering, and so we use GenAI to support the code documentation in order to be very fast in working re-engineering of legacy solution and to propose our solution too. The most important goal in this year is an in-house solution based on Llama 3 and on in-house NVIDIA Digit. We pre-order a couple of of machine from NVIDIA in order to cut the connection with the foundation. So in order to specialize the GenAI solution directly in an in-house solution. This is very important for the market. Well, for the market, once again, it's very, very big topic in bank market. Our teams are skills are, of course, based on Python, Java, and SQL. And so that's all. These are my my references. Thank you, and have a good luck with your research.
Okay, so thank you again. Then we have gunpowder.
Okay, can you hear me? Good morning, everyone. My name is Antonio Bertoldi, and I'm a business review manager for Seidor Gunpowder. And Seidor Gunpowder is a company that is based in L'Aquila and is founded 10 years ago here in L'Aquila as a spin-off of the University of L'Aquila. And in the meantime, we have evolved, and now we are more than 90 professionists that have been acquired by a multinational that is called Seidor, and it is based in Spain. In the board of the company, there is also Michele Framini, that is a computer science professor of University of L'Aquila. Our mission, as I said, is to develop solutions both for private and public companies. In the first days of Gunpowder, we born as a IT consultant company, strongly focused on CRM. We are one of the top 10 system integrators for Salesforce in Italy. But nowadays, we have involved our competencies and the range of our products with a good focus in artificial intelligence. Since 2022, we have started acquiring a lot of professionists for I specialized in artificial intelligence, and actually we develop both solution and consultants more strictly related to machine learning and artificial intelligence. As a part of our okay, let's jump to our experience. I divided the experience, as you know, in the different cluster of artificial intelligence. For the predictive AI, we have 2 or 3 very milestones that we have raised in our years. In the first one, we have developed a strong collaboration with one of the most important automotive industry in Italy. For NDA agreement, we cannot say the name of this this company, but we have done with them. Practically, our work is split into macro pillars. The first one is the data analysis. We have built the vehicles for R&D of a very next generation data logger that transmit to a computer a lot of data related to these cars. And then we have provided and developed a data analysis platform with Grafana, so that the R&D of this company can directly see the main aspect of the vehicle during the tests and on-road testing. The second one, that is more tricky and more challenging, is transform the static vehicle maintenance that is the most common that we have here in Italy and in the world to a new paradigm that is a condition-based maintenance. With the use of machine learning, we try to predict how a vehicle can have to be maintained based on a lot of data that can be retrieved, such as the number of kilometers, the speed, the usual speed of the driver, and so on. Another work that we have had near here in L'Aquila is with Sanofi, that is a very important pharmaceutical company that is based here in L'Aquila. With them, we have developed an IoT system installed directly on the supply chain of Sanofi in order to predict and analyze the status of the product that the pharmaceutical build with the supply chain. It is very important due the supply chain for pharmaceutical have a very high quality constraints that we need to respect. Another experience that we have is on computer vision. This is Restart. We have built a platform that can, the focus of this platform is the managing of disasters, geographical disasters. Let's imagine that in case of geographical disaster, we can send drones that can directly keep data and images from the site of the disaster. After that, it is immediately transferred to a central unit that will collect that data, and with the computer vision, we perform a first analysis of what is involved, humans, animals, or streets, and so on. Another very important work. Another important work that we have made is for the oncological diagnosis. We have built this machine learning routine that permits us with image recognition to predict exactly 96.97% of the oncological diagnosis specified for the colon rectum organ. Last of our experience is based on generative AI. First of that is Core, that is a platform that will permit to common people to build and program cobots. As you know, cobots have a strict related programming language that is owned by just a limited knowledge of people that can program that very quickly. Our tentative is to build a higher level of human language so that every people can directly communicate with cobot and let's practice of him and implement and learn of the cobot have to do. At last, in the last month, we have built a framework for generative intelligence, artificial intelligence, that is called Janus. Janus is, the purpose of Janus is to propose a framework that is LLM independent. You can use all the LLM that is provided and make the services and the product for built with this framework available for all kind of software solution and system that we have built, because we have developed a strong REST API level that will permit Janus to talk directly with your systems. Okay. As I said, the key feature of Janus is the ability to use different AI models in order to test the best for the use case. It's the integration between Janus and the other products is very, very easy because we have developed a strong API system. We have built also a strong pricing and regulation model so that it is very, very quickly to reach your interest and your meaning. After that, I am finished, and I hope your best for your research, and thank you for your attention.
So let's go down for some fruit and some coffee. And then we go all together to the Modern Art Museum, which is like a 10 minutes walk from here. Okay?